Hey everyone, I Abhinav Negi once again welcome you all on this special Maha Marathon of surveying. Tonight, the complete surveying will be done, including all chapters, including all topics. Okay, so guys, even that portion that is engineering services examination area volume, that also will be doing, but at the end. So first of all, we'll be doing the complete surveying from gate point of view, complete each and every chapter, each and every concepts with numericals, and then further on at the end we will be doing this area volume, that is only in engineering services. A warm welcome to all the champions right out there in the comment box. I was seeing many names there: Gajula, okay, Prashant, Hari Prasad, Girish, Prince, Amar. Okay, many students. Okay, so how is the Josh, guys? Everyone, are you ready for this session? Are you ready for this session? Tiksha, Padma, Eunice was our prize winner also. He got the prize. In Eunice got the Eunice and one more one that was from mechanical got the prize in Som. Eunice and Manas. So they have received the cash prize, and then in soil it was, I'm not getting the name, Prince and Aman from. Prince from Punjab and Aman from Allahabad. Yes. So all are super excited, guys. Please like the session. Everyone, please make your presence by liking the session. So guys, this is about me. I have 11+ years of teaching experience, done my MTech from IIT Delhi and all India rank 164. This is nothing coming in the examination. Okay, yes, these two sessions I'll be coming. Ask me anything, and one more session that for every single minute in the examination you have studied thoroughly throughout the year. So how to utilize, what is the proper sequence? Should we attempt 1 maths question, 2 maths question? Should we attempt maths first, aptitude plus, technical first? That everything I'll be telling you. Okay. So this is the complete schedule. So steel, environment, geotech, fluid mechanics, these are done. Now tonight is this, and then it will be surveying on the next day. That is structures next day by Krishna sir. Okay. So this session will be Krishna sir. This will be at 10 a.m. This will be 10 a.m. Okay. The complete Maha Marathon of structural analysis by the expert himself, Krishna sir, will be taking this tomorrow. Okay. I'll be sharing this link also in my Telegram group. Okay. Now, guys, this is my Telegram, Civil by Abhinav sir. You can join me here, guys. Okay. And this is one workshop that will be on how to ace GATE 2024 with college and job. This will be on 10th of Jan. And 7 success mantras from beginner to a top in GATE 2024. This will be 15th Jan Sunday at 12:30. So if I talk about the surveying, then guys, surveying, let me tell you, there are various years in between where surveying was not asked of any marks. That is why many people will be telling you that average marks of surveying in last 20 years or average marks of surveying in last 25 years is so and so on. That is absolutely wrong. Because in last 20 or 25 or 30 years, they are also concluding this data. And this data surveying is 0. But of course, now surveying will not be coming 0. Okay. Now surveying will not be 0. So please, if somebody is telling you the average last 20 years data, 25 years data, take this as useless data for you. Because now let me tell you, in 2022 also, it was around 4 marks. Okay, so now surveying will be 4 to 5 marks. And I always, even I am a geotechnical teacher. It is not like I am not a geotechnical teacher. I am a geotechnical teacher. Geotechnical, whenever I am teaching, I never said that it is most important. Yes, I said that yes, it is coming of highest marks. And also, simultaneously, I am saying that highest marks is the most important. That doesn't mean. Let me give you an example. Suppose soil mechanics is coming of 15 marks. Surveying is coming of 5 marks. But the soil mechanics syllabus is more than 3 times of surveying. Soil mechanics syllabus is more than 3 times of surveying. Okay. So it is not like that. You have to see the marks with respect to syllabus ratio if you want to check the importance of a topic. In 2015 to 22, guys, among all subjects, yes, geotechnical, environment are highest marks. Okay. But still survey is also decent. 5 to 6 marks it is asked, and 5 to 6 marks it will be asked. But important thing is that syllabus is very small. In surveying, if I compare the last 30 years, then traversing leveling are important, and if I compare last 5 years here also, then traversing and leveling are important. Okay, so various maximum questions are asked from compass surveying, that is declination, local attraction, then it is latitude departure, and then leveling. So from these 3 topics, compass, traverse and leveling, 80 to 70 or 90% sometimes questions are asked from these 3 topics. Okay, so guys, this is the correct sequence of studying. Okay, we'll study each and every topic one by one. I'm good, Arun, I'm good. Okay, so this is the sequence in which the surveying should be done, and almost same sequence we'll be taking in this particular marathon also. So second paper GE syllabus, if you are talking, I'm not getting geomatics, not, it will be particularly surveying. If you are talking of the second paper, that will not be covered here, Sai Babu, then you can leave. Okay, so these 2 topics are in engineering service examination. Okay, area volume I'll be doing at the end. Astronomy I can provide notes. Okay, so all these chapters will be done today. All these chapters will be done today, guys. Area volume and astronomy is only in engineering services, not in GATE, but let me tell you, I'll be doing this engineering service part, area volume also. So let's begin with the chapter 1, guys. Please put a heart sign on the comment box and please like the session by marking your presence. Everyone, I already told you the logic of liking is nothing. 39 like, 390 like, 400 like, nothing I will be getting. I every time tell the logic is simple, that more likes, then YouTube recommend that video more to students. And if I have done some effort in making the PPT, if I am doing some method for the next few hours, of course that is a human tendency, that I want that more and more students should be enjoying this. Ready? So please tell me your most weak topic or weak chapter among all. Tell me your most weak topic or most weak chapter among all. Everyone. Okay. Okay, GIS, GPS, photogrammetry, curve, tacheometry, curve. Okay, so what I am getting from here, that means that all conceptual topics are on your tips. That all conceptual topics are on your tips. Theory of errors is important. I will get confused, and also relief displacement. Okay, Rahul. So that means the photogrammetry, many students are having doubt. Okay, let me tell more detail those topics. Okay, theodolite, sir. Okay, let's begin with chapter number 1. Okay, so guys, please don't write anything which is already written here or which I will be writing, because that PDF I will be giving you in my Telegram cell by Abhinav sir. So whatever I am writing here, please don't write. I will be giving you this. Okay, so if any other point is there, then you can write it. Okay, this include all topics, all chapters, all concepts, and few numericals also. Okay, let's begin with chapter number 1. Okay, introduction. In this chapter 1, we'll learn about surveying, that what we are going to do in the other chapters. What we are going to do in other chapters, that we'll be studying in this chapter. Okay, now please see the process of plotting a thing that is in the field, in the map, that is called surveying. Or in a larger way, if I tell you that surveying is the art in which we determine the position of various points on the earth. In which we determine the position of various points on the earth. Okay, relative position. Now those positions can be drawn numerically, can be shown to the people numerically, or through graphically. Please guys, concentrate on my words rather than all these things. Let me start from the beginning. The objective of surveying, the purpose of surveying is to plot various points either numerically or graphically. I'm again repeating, the purpose of surveying is to determine the position of various points on the earth. Where is Brazil? Where is Delhi? Where is Mumbai? Where is Vizag? Where is Telangana? Where is Bangalore? Now when this is the main objective of surveying, to find the relative distance. The distance between Delhi to Bangalore is more, or the distance between Brazil to Bangalore is more. The relative position has to be determined, and after determining the positions by angle, distance or whatever altitude, after finding the distances or angles or height or whatever, we present them either numerically, like Delhi to Bombay distance is this, Delhi to Kolkata distance is this, Delhi to Vizag distance is this, Brazil to Vizag distance is this. Writing all distances, okay, either numerically. Yes, team MCQ is always with me. Thanks for all your support, teams MCQ and Mohit. Okay, so either we represent those distances numerically, those values numerically or graphically. Now again, if I am representing those things graphically, then again there are two things, that is plan and survey. Guys, you have ever wondered that sometimes a piece of paper there is some drawing on that, sometimes we call it map, sometimes we call it plan. So what is the difference between map and plan? Please let me know. What is the difference between plan and map? Sometimes not survey, sometimes we call it plan and sometimes we call it map. Sometimes we call it map. What is the difference? Guys, map and plan both are the drawings, but plan is a large scale representation. Plan is a large scale representation. Large scale, and map is a small scale representation. Map is a small scale. Like plan will be in the terms of scale 1 by 50. Map will be 1 by 10 lakhs. Okay, there is, guys, no boundary line between them. That after 1 by 10,000 will be saying that it is map. Before 1 by 10,000 will be saying it plan. There is no boundary line. It is not like that I am not knowing. Okay, there is no boundary line that after this is map, this is plan. Now see, if your house you want to draw in a piece of paper, then even 1 by 50 scale or 1 by 100 scale or 1 by 200 scale will be sufficient, or at max 1 by 500 scale will be sufficient. By reducing your house 500 times smaller, yes, it can be plotted on a chart paper, on a piece of paper. Yes, it is possible. It is possible. But if you are talking of Madhya Pradesh, if you are talking of Karnataka, if you are talking of Andhra Pradesh, if you are talking of India, then that whole big area converting in a piece of paper is not possible with a scale of 1 by 100 or 1 by 200 or 1 by 300. Reducing India by 300 times will not make it in a piece of paper. So there the scale will be 1 by 10 lakhs, 1 by 20 lakhs in this way. Got it, guys? Got it? Okay. So either whatever the data we obtain in the surveying is the main objective of surveying is to find the relative positions of various points on the earth. Now this and this, and relative position is also in terms of height, that how much Kathmandu is higher than this, that we'll study in leveling. That how much Kathmandu is higher than Delhi, how much the Himalaya is higher than Vizag, that we will do in leveling. Now the distance between Vizag and Delhi, the distance between Bangalore and Chennai, that is the distance that we'll do in chain surveying. Now the orientation of Kolkata, Bombay, Chennai, Jaipur, the orientation that we'll do in compass surveying. Okay. Now this is the numerically, graphically I already told you. Now can you tell me what is the shape of Earth? Can you tell me what is the shape of Earth? What is the shape of Earth? Let me tell you, guys, many people say the shape of the Earth is sphere. Shape of Earth is sphere, but no, sphere has a constant diameter. Here this polar axis joining the poles, and here this is equatorial axis. Here this is the equatorial axis. So equatorial axis is bigger than the polar axis by 43.5 kilometers. Equatorial axis is bigger by 43.5 kilometers. This can be asked in 1 mark. Okay, usually GATE will not be asking such data type questions, but other exams it can ask. Okay, the equatorial axis is bigger. Now someone says that the shape of the earth is ellipsoid. Why they shape ellipsoid? Because the green earth at the equator, this is slightly ellipse. So somebody call it elliptical. Now somebody called the earth as ovoid because our earth actually if we see from moon, okay, actually our earth, if we see from moon, then guys the southern hemisphere is bigger, northern hemisphere is smaller. Somebody call it ovoid. So guys, actually earth is not perfectly elliptical, not perfectly sphere, not perfectly ovoid. So a new name is given to earth and that name is geoid. The new name is given, that name is geoid. Now what is geoid? What is geoid? Guys, see, this is a bottle. This is not exactly cone, this is not exactly cylinder because the diameter is not constant. Diameter here is less, diameter here is bigger. So there is not perfectly sphere, perfectly cone, neither perfectly cylinder. So what is the name? Let me tell you the shape of this will be. Now what is the shape of this? Similarly, what is geoid? Geoid is the shape of earth. Okay. Yes, actually the earth is not sphere, but for all calculations in surveying, we will be assuming the earth to be sphere and radius will be equal to not 6400 that you study in your school. It is 67370 kilometer. Actually earth is not sphere, but for all calculation purpose we will be taking this as a sphere. Okay. Now there are some definitions. What are level surface? So level surface, if this is the mean sea level of earth, so any line which is parallel to this mean sea level, any line which is parallel to mean sea level is called level surface. If I am talking in terms of 2D, level surface, cutting this smart board like this, level surface. Okay, like this. I hope now you will get it. This surface, level surface, and any line on the level surface, is level line. Okay, any line on the level surface is level line. Why the name is level? Let me tell you the explanation. Guys, suppose mean sea level is at zero elevation. Suppose mean sea level is at zero elevation. So the points which is having, say, let me go 1 meter above, going 1 meter above, 1 meter above. So this orange line will be having how much elevation? This orange line will be having how much elevation? This orange line will be having how much elevation? This will be having elevation of 1. Okay, this will be having elevation of 1. Okay, all these points will be elevation of 1 because, or altitude of 1 because they are 1 meter above. So actually the level line which is having same elevation. Yes, Rahul, namaskar. Rahul Sodhi also, Rahul Sharma also. Actually the line which is having same elevation is level line. So that is perpendicular or that is parallel to the earth surface. Because all these lines now are at 1 meter up, are at certain distance above. That distance be x. All these are at x distance away. So their heights, their level is x. Have you got it? The lines which are having same elevation, the lines which are having same altitude are actually the curved which is parallel to the earth surface. Now, what is horizontal plane? So suppose this is our earth, and on earth at a particular point, if we draw a tangent, then that plane, if I talk in 2D, that is called horizontal plane, which is tangential to the earth surface at that point, and any line on that horizontal plane is called horizontal line. What is the great circle? So a great circles, see, suppose this is the sphere, let it be earth. Okay, so any circle where the radius of that circle is same as that radius of earth, radius of that circle is same as that radius of earth, radius of that circle is same as that radius of earth, that is called as great circle. And if any other circle like this one, okay, these are small circles, radius is smaller, same thing we'll be studying in celestial sphere also in astronomy. Now what is spherical triangle, guys? This is a spherical triangle. Now see this, these are three great circles, one great circle, and one more great circle, like these three great circles, two in. 1, 2. Great circle means where the radius of that circle is same as that of earth. 1, 2, 3. Of course I am not showing the behind the earth. This is 1, 2, 3. Now any triangle which is formed from the intersection of three great circles is called as spherical triangle. This is a spherical triangle. Angle is A, angle is B, angle is C. Side opposite to angle A is small a, side opposite to angle B is small b, side opposite to angle C is small c. Okay, so the spherical triangle should be having all three sides are the part of great circle. All three sides are the part of great circle. Now here, guys, it is not like plane trigonometry. In plane trigonometry, if this is C, this is A, this is B, angle A plus B plus C is equal to 180 degree. This is in plane surveying. That A plus B plus C is equal to 180 degree. Here, what are the properties of these circles or these angles? That here in spherical triangle, it is not a plane trigonometry. The sides are curved here. So the angles here are 180 to 540. Okay, and sum of three sides, here sides are also represented in degrees, that is 0 degree to 360 degree. Spherical angle, one spherical angle will always be less than 180 degree. Angle A less than 180, angle B less than 180, angle C less than 180, and summation will be 180 to 540. Each side of spherical angle is also less than 180 degree. Now suppose the angle of spherical, see, in plane trigonometry the sum of three angles is constant, 180 degree. In spherical triangle it can be anything between 180 to 540. Suppose it is 200. So 20 degree is called spherical axis. Anything which is more than 180 is called spherical axis. Suppose the sum of angles is 210. So spherical axis will be 30. Suppose the sum of angles is 360. So from 180 it is 180 extra. So 180 is the spherical axis. Spherical angle, surface area of a spherical triangle is less than 2 pi r square. R is the radius of earth, and great angle is what out of these three sides now, whichever is the biggest side. Suppose C is the biggest side, then angle C will be the biggest. Suppose A is the biggest side, so suppose angle A will be the biggest. Have you got it till now? Give me yes or no. Everybody on the comment section, guys, come on. Okay, now guys, surveying can be broadly classified in two ways, plane and geodetic. In plane surveying means that you are considering the earth to be plane. In geodetic surveying means you are considering the earth to be its actual shape, that is geoid. So guys, of course it is very obvious that if you see earth from moon, you will be looking like curve, because you are seeing a lot of it. You are seeing a lot of earth part. But if right now I am in my home, I am in my Delhi, suppose I go to my society's football ground, so I'll be assuming that earth is flat. So if you're observing a small part, it is flat. But when you're observing the big parts from here to here, then you find distinction that here earth plane is different and curve is different. Okay, so when the area is more than 195.5 kilometers square, you have to consider earth as geodetic surveying. You have to consider earth as curve. For small areas, you can consider earth as a plane also. Okay, though 195.5 square, if it is less, you can consider it to be plane. For more than 195.5 kilometers square, you can consider it to be sphere. Got it? Everybody? In plane surveying, you should be doing plane trigonometry. in plane surveying, you should be doing plane trigonometry. Okay, in plane surveying, you should be doing plane trigonometry. Okay, and in geodetic surveying, since now you are working on a larger parts, in small parts, yes, you can assume the sides to be plane. From Delhi to Noida, very near. From Hyderabad to Secunderabad, very near. You can consider that it is a straight line. But from Delhi to Brazil or from Delhi to Kolkata, that much huge distance, you cannot consider it to be plane. So there you have to work on the spherical angles. Okay. Now in every 18.5 kilometer, the actual distance of the earth is curved na. Actual distance of the earth is curved na. Actual distance of the earth is curved na. On every 18.5 kilometer, the plane trigonometry and geodetic trigonometry, the difference will be 1.52 centimeter. It is 18.5 kilometer minus 1.52 centimeter. Horizontal distance will be smaller. Okay. Now there are various types of surveying. Topographical surveying is it is used to obtain the natural and man-made features of the earth. Natural and man-made features of the earth. Even hills also, buildings also, rivers also, bridges also, everything. Okay, the scale here is 1 by 25,000 to 1 by 10 lakhs. Now engineering survey is used to done the engineering works like building, like canal, sewer, highway, bridges, and like this, and scale is given here. I'll be giving this PDF where no need to write down. Okay. Now cadastral survey is used to represent the property boundaries. Okay, now this is China, this is Pakistan, and this is India. Okay, and guys, when we are doing the surveying in these cadastral survey, the property boundaries between the two neighbors might be states, might be countries. Suppose there is a property boundary between Pakistan and India, then there will be even the area is smaller than 195.5. Even there the area is smaller than 195.5. Still you will be doing the geodetic surveying. Still you will be doing the geodetic survey because there every 1 millimeter is not important in terms of cost wise, but every 1 millimeter is your pride. Okay. Now hydrographic survey is done near the water bodies. Astronomical survey is done used to determine latitude of a place, longitude of a place, or time at a place. Okay. Geological survey is obtain the information about stratum of earth, like how much is the clay layer, how much is the sand layer, how much depth is the water table. For that geological survey is done. Now all these surveys are based on the purpose. What is the purpose? Now based on instruments we are having chain surveying. In chain surveying we are only measuring the lengths. Remember this point. In chain surveying we are only measuring the lengths. Okay. Another is by measuring the lengths we are finding the various points on the earth's surface. After that we are taking the reading. Coming to the home we can draw a plan or map. But in the field we are only doing the readings, only the length reading here. In compass survey we measure one angle also and one distance also. Okay, in leveling we are doing something that will study this, or actually this is our syllabus na. This is our syllabus. Classification based on instrument is our syllabus. Classification based on instrument is our syllabus. This is our syllabus. This might be you are learning this first time. Classification based on instrument is our syllabus. Okay, so chain surveying we are measuring the lengths only. Compass surveying, a compass is used. Okay, and lengths are also taken. Okay, in leveling we are finding the heights. How much height is Kathmandu than Delhi? How much height is Delhi than Mumbai? Like this. Theodolite survey also we are measuring the angles with the help of theodolite. Okay, in plane table survey this is the only survey. This is the only survey where we are measuring and plotting simultaneously. On all other surveys like chain survey, like theodolite survey, like compass survey, we are only taking the readings on the field. Then coming back home in the night, eating dinner, putting AC in the 16, in summers I am talking, putting AC in 16, and then we are doing the things. Then we are making the plan, making the map, anything. In plane table surveying, on the ground itself, we make the plan and map. Tacheometric survey is a survey in which horizontal and vertical distances are measured. Okay, photogrammetric survey is that we are not drawing map, we are not drawing plan, we are taking photos, and from those photos we are finding the information. Now how all these will be done, will be telling you. Before that, let me come to the two principles of surveying. There are two principles of serving. One is from whole to the part. That is, suppose this is a big area. Okay. Now you have find the control points. Control points are the points where the location of those points, the detail of those points are known. Control points can be inside also. So now these control points are drawn. Now working from whole to the part. Now we are going inside. Now we are going inside. Now we are going inside. From whole to the part. Okay. From whole we are going to the part. That will reduce the error. If you go from part to whole outside, so might be you go outside the area also. So whole to the part. Okay, we are working on small triangles or polygons here. We are working on small triangles or polygons here. Why? Why the whole area we are not doing? We are dividing into various parts. Let me tell you. Guys, if you find the lengths and angles for a small area, then the chances of errors are less. In this marker, the error you might be doing of not 2 meter, 3 meter like this. You are doing the error of might be kilometer. Oh, sorry, mm. 1 mm error, 2 mm error at maximum. Even if you are drunk, still you will not be doing the errors in meters. But when you are measuring the distance between Delhi and Bombay, the error will not be in millimeter. It is obvious that error there will be in meters, might be kilometers. So if you are doing the survey from small part, then covering the whole part, that will reduce our errors. The second is to obtain a point by at least 2 measurements. Like A and B are already established points. From here measuring C by distance AC and BC. So by locating a point C by 2 measurements. 2 measurements can be length, like in chain surveying. In chain surveying, we only rely on the lengths, not on angles. We only rely on the lengths. In chain surveying, we never talk about angles. No compass, no theodolite. Okay. So in chain surveying, we locate a point. See, the principle is that we should locate a point from 2 measurements for any surveying. Chain surveying, compass surveying, theodolite surveying, any surveying, we should be locating a point from 2 measurements. In chain surveying, those 2 measurements are length only. Now here it can be that from AB are already known points. We go to angle, but in this angle how much to go? So distance has to be also find out. Okay, even the distance can be here also. So theta and a distance can be AC or distance can be BC. This is done actually in compass surveying. This is actually done in compass surveying or theodolite surveying. One angle is taken and one distance is taken. One angle is taken and one distance is taken. Suppose these are two established points, A and B. Now from A and B, you have to go here. Suppose theta is also known. In theta, this, how much distance, so distance was also be required to measure to find the point. Now here, 2 angles are taken. From A and B, theta 1, theta 2, we got a C point. This is done in chain surveying. One angle and one distance is done in theodolite or compass surveying. If angle is taken from theodolite, it is theodolite surveying. If angle is taken from compass, it is compass surveying. And here it is called as triangulation. Yes, of course, yaar. Okay. Now moving further, guys, let me tell you one thing. Please let me know in the comment section, everyone. Length is taken by tape and chain both. Which is more accurate? Tape or chain? Tape or chain, which is more accurate? And angle is also taken from compass and theodolite. Which is more accurate? Angle is also taken from compass and theodolite. Which is more accurate? Which is more accurate? Yes, everyone, yeah, excellent. Shweta was also there in that time also. Okay, excellent. So here this is more accurate. Here theodolite is more accurate. Tape is more accurate because in tape we can find small values also. Chain, there are no markings. One link is of 20 centimeter or whatever. In chain, suppose in chain These are links. Like now suppose this is 20 centimeter. Can you measure 142 centimeter from this chain? No. Either you will be measuring 140 or 160 because there are no markings. But in tape there is marking also, you can measure 142 also. Similarly, the least count of compass is 30 minutes. So from compass you cannot measure the angle 56 degree, 26 minutes, 32 seconds. No. The least count of theodolite is around 10 seconds to 20 seconds. Okay, so theodolite you can measure smaller values also. Okay, now let's come to the scale. Everyone guys, please, everyone. See here, concentrate. Now guys, scale is the length of a line on plan or map divided by the length of same line on ground. Suppose I am saying that scale is 1/1000. That means if it is 1 centimeter on the map, it is 1000 centimeter on the field. If I am saying it is 1 centimeter on the plan, that is 1000 centimeter on the field. If I am saying 1 millimeter on the plan, then it is 1000 millimeter on the field. So scale is the ratio. Now scale, I can see represent scale is engineering scale. Engineering scale is like 1 centimeter. Engineering scale is 1 centimeter is to 1 meter. That one, of course, 1 meter in the field is equal to 1 centimeter in the map. Representative fraction is, if the same scale I am representing in fraction, then it is 1/100. In representative fraction, both are same units. If you are saying 1 centimeter in the field, it is 100 centimeter. 1 centimeter in the map, it is 100 centimeter in the field. If you are saying 1 decimeter in the map, it is 100 decimeter in the field. If you are saying 1 millimeter in the map, it is 100 millimeter in the field. Here both are the same ratio. So same engineering scale is also this representative fraction. One is a graphical scale. Guys, sometimes or most times, suppose this is the map of India. Please don't laugh. Suppose this is the map of India. Excellent map I have made. Okay. You have seen many times that is written like something like this as 200 kilometer. Have you seen this? This is graphical scale. Have you seen this? Have you seen this? Yes, this is 200 kilometer. Now how to use this scale? Suppose we go with the Natraj scale. Suppose we go with our simple Natraj scale and measure the distance here as 1 centimeter. Suppose this is 2 centimeter. From Natraj scale, it is not written. I am just measuring with Natraj scale, it is 2 centimeter. Okay. Now, the distance between Delhi to Lucknow, suppose this comes to be 6 centimeter. Okay, 6 centimeter. Guys, in whole surveying na, when I am drawing a point on the map, I will be writing with small letters in whole surveying. So distance between Delhi to Lucknow is 6 centimeter. Then 2 centimeter is 200 kilometer. 2 centimeter is 200 kilometer. 2 centimeter is 200 kilometer. So 6 centimeter will be 600 kilometer. 6 centimeter will be 600 kilometer, like this. This is the graphical scale. Okay. Now, guys, I want to tell you one thing, but this all you will get in PDF. Okay, if you study this now, you will get nothing. You'll get this all thing, whatever is written here now, you will get nothing. Let me tell you, I will give you more detail without using all this, and you will be getting more easily. That is why in PPT everything should not be written, because if everything is written now, then that was like a boring lecture that I used to take in IITs. That everything is written, teacher, and go. So see, all these are here, good for your notes, but let me explain you everything. Without this. So let me take a new slide here. I don't want that in slides much. Many things are not written here. So whatever is this now, you will get it. New slide. Okay, see here. If I teach you in blank slide now, it will be better for you. Suppose this is a original map. It was made in 1980 and the scale was 1/1000. scale is 1 by 1000 and the map is something like this. Now in 2023 the map is shrunk. Guys, map never expands. If it expands, it will tear off. Okay, in 2023 it shrinks, and it shrinks such that the line here earlier x centimeter is now only y. So guys, scale, it is not graphical scale. Scale, if it is written here 1 by 1000, so what will be written here? 1 by denominator will be more than 1000 or smaller than 1000? Denominator will be more than 1000 or smaller than 1000? What will be written here? Smaller or bigger than 1000? Smaller, Ranveer is saying. Smaller, you are saying. Smaller denominator. Let me tell you here, neither smaller nor bigger. It will be written as 1000 only in small fonts. It is written here 1000 only in small fonts. Good, Prince. If it is written 1 by 1000, guys, bhoot nahi aa raha hai na. Ghost is not coming na. It will be written only 1 by 1000 but in small fonts. Okay, but that will not be the actual scale. That is because, guys, suppose this x centimeter on map. This x centimeter on map, on field it is how much? 1000 x centimeter on field, correct? Here y centimeter is also 1000x. The field distance will not be going to change. If I take a big map, if I take a small map, the distance between the Delhi and Mumbai is not changing. If I take big map, small map, Sri Lanka will be always smaller. If I take big map or small map, the distance between the Delhi and Lucknow will be smaller. Okay. Now, yes, it is shrinking from all sides in equal proportion. So now y centimeter on map is also equal to 1000x. The ground distance will not be changing, na? So the scale is mapped, scale of shrunk map is map distance by ground distance. So map distance is y and ground distance is 1000x. If you want to represent in 1 by, so it is 1000x by y. X is a bigger number, y is a smaller number. So it will 1 by denominator will be more than 1000. This is the scale. And guys, obviously the denominator will be bigger, because if this map can make, this is a shrunk map. If the original map can make 1000 centimeter on the field to 1, this is even a smaller map. This can make even 1200 to 1. So here, if you use this scale, this will be wrong. So you have to find scale differently for this. Guys, if this can make 1000 to 1, this can make 1200 to 1, 1300 to 1. It is even smaller. This can make 1400 to 1. Everybody on the comment box, I see me yes or no. Everybody on the comment section, give me yes or no. Everyone, come on. Everyone, please tell me, have you understood this? Okay. Now there is a term called shrinkage factor. Or it is called a shrinkage ratio. It is shrunk length by original length. So shrunk length y, original length x. It is also called shrunk scale upon original scale. So it is shrinkage factor, shrinkage ratio is ratio of y by x, or shrunk scale is y by 1000x. Original scale is 1 by 1000. If you solve this, this also will be getting as y by x. Okay, so all these things are written here. Okay, now if sometimes this is not, guys, this is not a case of wrong scale. Sorry, this is not the case of, this is not used for for shrinkage problem. Not used for shrinkage problem. This is what that map is not shrinking. This map is made on a scale of 1 by 100. And somebody is coming with drinking daru, with drinking beer, and he has calculated some distance by taking it as 1 by 50 scale. So map is not shrinking. In the same map he has used some different scale. Then this has to be applied. Okay. Sir, good news to share. Got selected for interview in GPS yesterday 2 days back and had complete main subjects from BYJU'S channel. Sir, thanks to all teachers. Thank you. Great, Dhruv. Great, guys. So, like Dhruv, na, many students from BYJU'S and Prep, you have seen the mock test interview also, na. Our engineering sir, many will tell that these are our students after the result. We have put the videos. Before the exam, their mock interview, before the exam. Rank 6, rank 7, rank 9, rank 6. Okay? Hassan Saab. Rank 7, rank 9 Vaibhav. Okay, rank 10. Rank 7 was Deva Mishra. Rank 9 Vaibhav. We have put the videos before the exam that they were doing the BYJU'S exam prep interview. And apart of couple of them, all are from our students, from our courses. Okay, and many students are here, so very congratulations to Dhruv Patel Bhai party from my side whenever you come to the Noida office. Okay, now moving here. Guys, not used for shrinkage problem. Guys, this is not shrinking. In the same map, in the same scale, it is not shrinking. We are using the scale. The map was prepared for 1 by 100, but we are using 1 by 50. Then these formulas has to be used. Guys, this thing that y by 1000x, where this scale is not the wrong scale. This is not the wrong scale. This is the correct scale for the shrunk map. Everybody on the comment box, please put a heart sign if you got it. Everyone, come on. Okay, now guys, the vernier scale is used to measure the small values. Okay, so guys, see the scale that we used in school, Natras scale. The scale that we used in the school, Natras scale. What happens in that Natras scale, na? If this is 0, this is 1 centimeter, this is 2 centimeter, this is 3 centimeter. So between 1, 2, 3, there are 10 division. 1, 2, 3, 5, 6, 7, 8, 9, 10. Like this. So from this Natras scale, suppose there is a line AB. So what you will be measuring? Either you will be measuring it as 4.2 centimeter, suppose, or you are measuring it as 4.3 centimeter. Either you are measuring it 4.2 or you are measuring 4.3. But this may be 4.265. This may be 4.267. This may be 4.321. Okay, so find the smaller values. We can use the vernier scale. Okay, we use the vernier scale. Of course, the vernier scale is also a limit. It will give you a least count of suppose 0.01. Still you will be measuring up to 4.23, 4.25, but the real value may be 4.230000000092. Okay, so nobody in this except Rajnikant, nobody can find the exact value, true value of anything in this world. We can only find the values up to which the least count is allowing us. Okay, now there are direct vernier. See, leave this. Let me tell you. End division. There are two scales we are using simultaneously. Suppose this is main scale and suppose this is vernier scale. Now, in vernier scale, there are suppose n divisions of vernier scale is equal to n minus 1 division of main scale. So, suppose here are 5 divisions here, or suppose here in vernier scale it is, suppose n is 5 or n is 4, so 1 2 3 1 2 3 4 division. So for if 4 division of vernier scale, then main scale division will be 3. I am telling you the logic, don't worry. So here if this is equal to V, one division is equal to V, all these divisions are of V, like this, and here it is S. So least count will be, the smallest value that is visible to us is V S minus V. Least count is S minus, guys see, this is the least count now that we can measure. This is the smallest value that we can measure, S minus V, and least count is S minus V, and we can see that from the statement definition of direct vernier that n divisions of vernier is equal to n minus 1 divisions of main scale. So from here the V value is n minus 1 into S by n. Putting this V value here, putting this value V value here, you will getting least count is S by n. Now my questions, that book will not be taking you here. Everyone, guys, if suppose this is 19 centimeter thread, there is thread, no marking, and suppose this is 18 centimeter thread. So from this 19 and 18, what we can measure? Suppose, okay, these two are almost equal. Okay, suppose this is the vina, this is a tube. Now these two are, this is a tube, this is 19 centimeter. मेरे टेलीग्राम में मिलेगी भाई. This tube is 19 centimeter and this marker is 18 centimeter. So how much we can measure from combining these two? This is 19 and this is little smaller, 18. So from 19 and 18, what we can measure? Smallest value. What we can measure the smallest value? 1 centimeter. So that means 19 and 18 we can measure. I am taking live class from my home. From 19 to, okay, so from 19 and 18 centimeter, this is 19 centimeter, this is 18 centimeter, the smallest value that we can measure is 1 centimeter. Got it everyone? Got it everyone? So like here, if it is S and this is V, suppose this is division is S, this is V, the smallest value we can measure, the smallest value we can measure is S minus V. Now guys, for all other scales I am not going in detail. For all other scales also this is same, answer will be same. Least count is S by n, the derivation is given here. Now my answer is, आवाज आ रही है उसकी. Now my question is, everyone, why it is always, see this n to n minus 1. Let me tell you of, leave this, I make you understand all these things. What happens to the scale? Like this is another vernier, retrograde vernier. This is direct. Now retrograde vernier, what happens? Here n divisions of vernier scale is n plus 1 of main scale. N can be anything. 60 of this should be equal, can be 61. 36 of this can be equal to 37 of this. Suppose this is vernier scale. Suppose this is main scale. Now n divisions of vernier scale is equal to n plus 1 divisions of main scale. N division of vernier scale, this is 1, 2, 3, 4 is equal to 4 of this is 5 of this. So this will be smaller. This will be smaller. This will be smaller. 4 division of this can be 5. And this n can be anything. It is not like 4 and 5. It can be anything. 1, 2, 3, 4, 5. So out of this, what is the smallest value that we can measure? This one, na? This one, na? So that is V, that is S. Division of one value of vernier is V, this is S. So least count is V minus S here. And the condition here is n times of vernier is n plus of 1 of main scale. So from here V value is n plus 1 into S by n. Putting V value here, least count again comes S by n. Okay, least count for, even for extended vernier also it is S by n. Now my question is that guys, why it is always written the person who has designed vernier? The person who has designed vernier, why he has taken like n of this is equal to n minus 1 of this, or n of this is equal to n plus 1 of this? Why? Can you tell me? Anybody? Can you tell me anybody? Why that person has taken something like this, n of this is equal to n minus 1 of this, or n of this is equal to n plus 1 of this? Why he must have taken like this? Can anybody let me know on the comment section? Everyone guys, come on. Come on. Guys, because if there is a football match and the score is 10-9, then 10, or the football match and the score is 4-3, 10-9 is very rare chance that a team score 10 goals and another team score 9 goals. So if the score is 4-3, if the score is 4-3, then those both teams are stronger, equal stronger. But if the score is 4-0, one team is very weak. So 4-3 means the teams are almost equal, and when n and n minus 1 is there, n or n plus 1 is there, then when both values are almost same, then both values are also, the difference will be small, and that is our objective, not to find the small values also. Have you got it? France versus Argentina 3-4. Not 3-4 yaar. Before penalties, it was not 3-4. 3 of Mappe, 2 penalties and 1 this, and 3 from there. 3-3 was there na before. Got it? Got it? Why it is n and n minus 1 or n or n plus 1? Because when both values are same, and when both values are same, the difference will be very, very small, and that is our objective, to find the small values also. Now do this. Least count for every scale is S by n, guys. S is the, what is S here? S is the one division value. S is the one division value of main scale. S is the one division value of main scale, and n is number of divisions of vernier scale with some divisions of main scale. Guys, at 11 we'll be having the break. At 11 we'll be having the break. So there is a theodolite. Of course, the plate of theodolite is circular, and the main plate, that means the main scale. The main scale of theodolite is divided into 1080 divisions. 1080 divisions. It is divided into 1080 divisions. So what is the value of one division? What is the value of one division? What is the value of one division? Theta. What is the value of one division? Theta. It is 360 degree are divided into 1080. That is also S na? S is the value of one division. S is the value of one division. S is the value of one division. Okay. So it is, if 360 are divided into 1080 division, so S is the one division value. So one division value will be 360 and it is divided into 1080 parts. N is the number of divisions. So 60 divisions of vernier are matching with main scale. So this will be 60. This will be degree. In minutes it will be multiplied by 60. In seconds it will be multiplied by 60. So answer will be 20 seconds. This is 360 degree na. So this value will be in degree. Multiply by 60 to make it in minutes. Multiply 60 to make it in seconds. Have you got it? Have you got it? Have you got it? Please let me know, guys. Everyone on the comment section. Everyone on the comment section. Please tell me. Please tell me. Please tell me. Okay. Now do this. Now do this. A plan drawn to a scale of 1 centimeter equal to 10 meter is now reduced in such a way, now it is shrunk. Okay, scale was 1 centimeter equal to 10 meter. 1 centimeter equal to 10 meter. Now it is reduced in such a way that that 10 centimeter line is now measures 9 centimeter. Now measures 9 centimeter. Now this is the reduced map. In reduced map we find some area 81 centimeter square. If this was 81 centimeter square, so what is the area on original map? This is the question. What is, if in the map it is 81 centimeter square, then what is the area on the original map? What is the area on original map? See, let me tell you. This you can assume to be square of 9 into 9. You may ask that, so it is never written the square. I will answer that also. This is 9 to 9. So if this is 9 into 9, so actually 9 of here is actually 10 of here. Okay. Whatever was 10 here, it reduced to 9. Whatever was 10 here, this is reduced to 9. So this, if this was 9 there, so here it will be 10 and 10. 10 and 10. And 10 centimeter is actually 1 centimeter is 10 meter. So 10 centimeter in map, if 1 centimeter is 10 meter, then 10 centimeter will be, if 1 centimeter is 10 meter, then 10 centimeter will be 100 meter on map, 100 meter on ground, 100 meter on field. So area will be 100 into 100. This will be A. This is the one answer. Now you will say, sir, it is never written it was square. Let me answer you that also. If it is never written, it is general statement, then for general statement, there is something, then for a particular it will be correct, na? For a particular thing, if something is not correct, if correct, we cannot say that for a general it will be correct or not. Sin theta plus cos theta for theta value 90 is 1. For theta 90, sin theta plus cos theta is 1. But we are not sure that every theta it is valid, na? But suppose there is some general statement, sin square theta plus cos square theta is 1. Then that statement is valid for every theta, because there the statement is written in terms of theta. That sin square theta plus cos square theta is 1. It is written in terms of general value theta. Then it is valid for every theta. But if I am saying that I am not saying sin theta plus cos theta is equal to 1. I am saying that sin 90 plus cos 90 is equal to 1. For 90 value it is 1. But for other values it might not be 1. Na? So if this is there, it is, the values are asking in the general way, then for particular way we can do it. We can do it. Otherwise, if you don't want to do like this also, it's okay. It's okay. So if here is the 81 centimeter square area, na, here, then what will be the area here? So this is one, first of all we are telling the formula. Formula is area divided by shrinkage factor ka square. Area on original map. 81 by shrinkage factor. What is the shrinkage factor? Shrunk length by original length. Shrunk length is 9, original length is 12. So shrinkage factor is 0.9. So 81 divided by 0.9 ka square. So this will be coming as 100. So area on the original map is 100. This is the formula, that whatever the area here divided by shrinkage factor square, this is the area here. Now even why to do this formula as this pure method aptitude? This is the pure aptitude, that area on original map is equal to, if the area here is 81, if the area here is 81, here the area will be bigger, here the area will be bigger obviously, here the area will be bigger obviously, yeah, area will be bigger here, because this was the original map, it is shrunk, after shrinking it is 81, so here it will be bigger, so multiply a bigger number, and multiply bigger number. See, this is reducing in the ratio of 10 by 9, 10 becomes 9, 10 by 9 becomes 9, 10 by 9, 10 is changing to 9, so multiply with same number to make it bigger, so same number 10, in 10 by 9 times it becomes smaller, it becomes smaller in the ratio of 10 by 9, same multiply it to make it bigger, since it is area so it will be square, so again 100, so once you got 100 here, 100 centimeter square here, so multiply with scale, so area on this, the area on field is map is 100 na, so area on ground, this is 100 centimeter square, multiply with scale, scale is 1 by 1000 na, here 1 centimeter is 10 meter, 1 centimeter is 10 meter means 1 by 1000, so multiply with scale, since it is area so 2 times, this will be centimeter square because 100 is centimeter square, so meter square it will be 10 ki power 4, so again the answer will be this. 3 methods I have told you till now. First method was square, second method was from formula, third method was from logic. Now going to the fourth method. Now up to now what we are doing, that converting this 81 to here 100, then converting 100 to field, we are doing this. Guys, find the scale of this. The scale of this is, scale of here is 1 by 1000, so scale here is bigger, so scale is here this much, and directly why go from here to here then multiply by scale, from now this is the area, this is the scale, so directly multiply 81 into this scale by scale square because it is area. Now directly why to go from here to here then multiply with scale to get the field, multiply with scale to get the field, directly from here you find the scale of this map, shrunk scale, directly from scale directly. Now this shrunk scale is the right scale of the shrunk map, shrunk scale is the right scale of the shrunk map, directly from here multiply the scale and get the value. Give me yes or no in the comment section, guys. Give me yes or no in the comment section, everyone. Everyone. Guys, I will give you break. You want break? You want break at 11. At 11 will give you break. Bunty, you can do this back and later on you can check this. I will give you a break. Just 10 minutes break, yeah, not much. Okay, which of the following the smallest scale? Out of these, which is the smallest scale? This is 4 by 1s, 10s, 100, 1000, 10,000 lakh. 1s, 10s, 100, 1000, 10,000 lakh. So it is 1 by 50,000. Okay. So this 1 centimeter is this 5,000. 5,000 meter. 5,000 meter. So 50,000. 5 lakh. 1 by 50,000. 1 centimeter is 50 meter. So 5,000. So smallest is this. Smallest is this. Smallest means biggest denominator. We'll see. Prashant will see after the break. Have you got it? Have you got it? Okay. Yeah. Which scale is not affected by shrinkage of map? This scale. Why? How? Let me tell you. See here. If this map is shrink by 50%. So here it will be written as on the scale. Here it will be written as how much kilometers now? 200 or 100? Here this is 200 kilometer. How it will be written now? 200, 100 or 400? How much it will be written now? How much it will be written now? it will return only 200 only and in small fonts. 200 in small fonts. Now the distance between Delhi to Lucknow, this is not written in map. Delhi to Lucknow distance is not written in map. This is not written in map. This I am measuring from Natra scale. So earlier it was 6 centimeter. So now it will be 3 centimeter. This I was measuring, it is not written in map. And earlier it was 2 centimeter length. So now it is 1 centimeter length. This I am measuring 2 centimeter is not written in map. In map it is only 200 kilometer written. In map it is only 200 kilometer written. So now 1 centimeter is 200 kilometer. So 3 centimeter will be 600 kilometer. So answer will be same again. Earlier also it is 600 kilometers na. So because here as the distance between Delhi and Lucknow or any of the two places shrinking, the same amount scale is also shrinking. So here this will not be causing any effect. Got it? Graphical scale. Now mistakes and errors. Nothing to remember in surveying here. Everything is aptitude. Everything is aptitude. Now guys, very large error is mistake. Like the true value between A and B is suppose 6.7 centimeter. This is the true value. And now you are measuring. Suppose you measured 6.8 centimeter, then you measured 6.7, then you measured 6.6, then you measured 6.5, then you measured 6.9, but from near away a beautiful girl. Yes, it is proportional everywhere same. Beautiful girl, Sundar Kanya is going on. And then when that beautiful girl is going on, instead of writing 6.9, you have measured it 6.9, but you have written it 69. Due to that beautiful girl, you forget to write down the point after 6. So the very big error is called mistake. Very big error is called as mistake. Okay? A big error is called as mistake. Okay, and reasonable errors are errors. Now what is error? Measured value minus true value. And opposite of this is correction. And no need to remember this also, yaar. Measured value minus true value. Let me just see you here. What is the error? Here measured value 6.8, true value is this. Error is 0.1, 0. Measured value minus true value minus 0.1. Measured minus true minus 0.2. So correction is true value minus measured minus 0.1. True minus measured 0. True minus measured plus 0.1. True minus measured plus 0.1. And it is called logical, yaar. I don't want to remember this formula, yaar. To make 6.7 correct, how much is required? 0. To make 6.6 to correct value, how much correction is required here? 0.1 plus 0.1. How much correction is required here? Plus 0.2. How much correction is required here? 6.8 to make 6.7 minus 0.1. Very logical, yaar. Very logical, yaar. Have you got it? Have you got it, everyone? Please let me know in the comment section, yaar. Come on, champs. Now these errors are classified in two ways. That is systematic error, also called as cumulative error. Another is random error, or also called as accidental error, or also called as compensating error. Let me tell you what is the systematic error. Suppose a tape of 30 meter. Suppose a tape of 30 meter. The markings are 30 meter. This is the 30 meter, but actually it is 31 meter. Either due to temperature it is increased. This will increase by a very small amount, not 1 meter, but let me assuming it. Or the company has made it wrong, the factory has made it wrong. Actually it is 31 meter and they are saying 30 meter, or due to pull, some Rajinikanth is coming and it is 30 meter. By any ways, it is actually 31 meter, but readings are only 30. Suppose I put this tape one time. So you will be saying 30 because markings are there up to 30, but actually it is 31. So what is correction? What is correction? True value minus measured value plus 1. Suppose this tape I put 2 times. Suppose this tape I put 2 times. So one time I am measuring 30 because markings are only up to the 30 na. So 2 times I will be measuring how much? 2 times I am measuring how much? 60 meter. But actually it is 31 meter. One time when you are making it one chain length, it is actually 31. So true value is actually 62. So making it correct, correction is plus 2. Simply 3 times. You are measuring it, every time you are measuring 30. So measured value here is 90. But true value is, one time is 31 na. So 3 times it is 93. What is correction? What is correction required here? True value minus measured value plus 3. What is the correction required here? Plus 3. So these are systematic errors. These are systematic. They are following a pattern. They are following a pattern. They are cumulative. Plus 1, plus 2, plus 3, cumulative. Following a particular pattern. And always remember, guys, when the chain is bigger, actually it is 30 meter, but actually it is bigger. So it is positive correction. And when it is smaller, it is negative correction. So these are systematic, cumulative. We can correct this. In second chapter, we study this. In second chapter, we study this. That correction due to temperature, correction due to sag, correction due to pull, correction due to standardization. All these are we study in second chapter, and we can correct this because they are following a system. Now random errors, accidental errors like this. Sometimes you are measuring big, sometimes you are measuring slow, and there is no pattern. The Sundar Kanya, the girl coming is making your errors. Okay, your carelessness, instrumental defect, anything. Sometimes you are measuring plus, sometimes you are measuring minus. They are random errors, accidental errors. We cannot correct them. These we will study in theory of error chapter. This we will study in theory of error chapter. Got it, everybody? These 2 sessions we are coming in next 2-3 days, guys. Okay, now here this is done, this is done, this is done. Then surveying right now. Structures will be tomorrow. The complete structures by the great expert of the subject itself, Krishna Yadav sir. That will be 10 a.m. in the morning. That will be from 10 a.m. in the morning. And you're going to find all these links. Sir's session also I'll share tomorrow in the morning. PDF, everything you can find here in the Telegram, Civil by Abhinav sir. These are the 2 workshops. Okay. Now, guys, let us move to the second chapter, that is linear measurement. That is also called as chain surveying. Then after that linear measurement, the important topics will be coming. Compass, traverse, level. 90% questions are asked from these topics. Okay. So let me study linear measurement. Everybody ready? Everybody ready? Please let me know, yaar. Come on. Come on. Everyone, please put a heart sign on the comment box. Are you ready? Everybody, come on. See, guys, main purpose of surveying is to plot an area on map and plan. And on map, always we project the horizontal distances. Okay? Always we measure the horizontal distance. Let me explain you. Suppose this is India. Suppose this is Chandigarh here. And in Chandigarh, suppose there is a mountain in very near to Chandigarh. And from that mountain, there is a peak of 500 kilometers above. And there is a place called Shimla. There is a place called Shimla. Chandigarh, very in front of this, there is a mountain, and on top of the mountain, suppose the place is Shimla. 500 kilometers. So guys, Chandigarh, then Shimla will be coming here. If very near to Chandigarh, not go to the actual India, and don't consider, suppose there is a city C, forget Chandigarh. and see, just after a distance of 200 meters, there is a strong long cliff of 500 kilometers and there is a place S. So S will be here in China in map. S will be here in China. No, S will be here only, na? Very near to Chandigarh or overlapping it. So in map always we show the horizontal distance. If the distance between A and B is L, so nothing to do with L, we'll be only projecting L cos theta on map. With L cos theta dividing by scale, whatever the value is coming, that will be projecting on map. Guys, actually the projection of map is a orthographic projection. If this capital letters is the actual letters, if the actual distance on the earth, A, B, C. So the projection is orthographic projection. A we are projecting here as A, small a on the map, small b on the map, small c. This is called orthographic projection. And whatever the distance between A and B, we are actually projecting the horizontal distance here. AB, BC like this. AB, BC like this. Okay? Okay? Now, guys, there are various methods of measuring the distances, chain, optical methods like tacheometer that will study. There are some instruments like EDMs also. Based on light wave, there is geometry meter and micrometer. Based on radio waves, there is dystometer and telometer. Based on infrared, is total station. I am again repeating. The measuring the distance, one is chain or tape. And there is some optical methods like tacheometer. D is equal to Ks plus C. And there is some instruments, electronics, from which we put the laser light and get the values. Okay. So, offset is, all these are not important. Now, what are the different types of chain? This is written here. I will provide you this in PDF. Okay, so what are the different types of tape? Cloth or linen tape, metallic tape, steel tape, invar tape. This is the most important. Why most important? Because this is most accurate tape. Why this is most accurate tape? Because the alpha value is very less. This is 64% steel, 36% nickel. This is very most accurate because the thermal coefficient is very less. So if alpha is very less, then L alpha delta T is approximately negligible, 0. So that means the 30 meter tape, if it is standardized properly, will be 30 meter. It will not be increasing much in summers. It will not be decreasing much in winters. Okay, but चलेगा भाई, रात तक चलेगा, ढंग से पढ़ना है तो. Okay, now there are instrument pegs. Pegs are there. Wood pegs are there like this to mark a particular point, and if you want to mark it for a larger area, permanent benchmark, then you can go for the concrete, pouring the concrete there. Now there are arrows. Arrows are like this. Now why arrows are there? Let me tell you. Suppose you are measuring 150 meter. Listen to me. But tape is only 30 meter. Suppose tape is, you are having only 30 meter and you have to measure 150. So leader is here, follower is here. They will measure 30 meter. Now follower will put one arrow here. One arrow. Then this is only 30 meter. They have to measure 152 meter. Then leader will come here. Then in the second step, leader will come here. Follower will go here. And leader will collect this arrow. So leader has one arrow. Now after again 30 meter, follower will put one arrow here. Now after 30 meter, leader will go here. Follower will go here. Now leader will have two arrows. Now follower will push one arrow here. Then again leader will go here. Collect that arrow. Follower will go here. After this, leader will be having now three arrows. Doing this again and again and after. Suppose after when the leader is having 9 arrows in his hand. That means how much they have measured? 270 meter. Suppose at the end of the day's work, leader is having 35 arrows in his hand. That means how much they have measured? 35 into 30. Have you got it? Have you got it? Please let me know. Guys, come on everybody. Guys, we cannot measure 2062 meter in a single way, na? 2062 meter we cannot measure in a single way, at least from chain. At least from chain we cannot measure it in a single attempt. So 30 meter we are going forward. In every 1 meter, leader is a one arrow. Okay. Now These are ranging rods. So ranging rod length is 2 to 5 meter, and there are some black or white strips of 200 mm, 300 mm. So one person is here with one ranging rod, one person is here with another ranging rod. Now suppose you are measuring 152 na, and I told you the story of leader and follower, but you have to measure the horizontal distance na. You have to measure the horizontal distance between 2 points na, because in map it is only the horizontal distance. It should not be like that. AB you are measuring like this, because actually the horizontal distance is projecting on the map na. Horizontal distance is projected on the map na, horizontal distance. So the two distance you should be measuring the horizontal one. Horizontal one. That means you should not be going like leader follower. The leader follower are not going like this zigzag. मजाक नहीं चल रहा है यहाँ पर. मजाक नहीं चल रहा है. So they have to go in a straight line, guys. So how to find the straight line? So one will be ranging rod at the end. One ranging rod will be here, and another person will be coming with ranging rod here, somewhere in between. If this person is seeing the ranging rod, all these ranging rods in a same line, that means he is not able to see this. Then that means it is collinear. If he is not able to see this, that means it is collinear. Otherwise, he will make his hand right or left to make its movement. That please go here, please go here. Have you got it? Have you got it? Offset rods are rods with slot meets at right angle. There are some hooks, slots at right angle to see the perpendicular distances. Cross staff. Now suppose it is on a line, this cross staff. So suppose this person is seeing here. So another person who is seeing from here, a person is seeing from here, then another person who is seeing from here, that is establishing 90-degree points. So put a cross staff on a particular line, and from here if you see, you will be seeing the 90-degree offsets. Have you got it? Have you got? Similarly, there is a instrument called French cross staff. Here the openings are like this for making different angles, 45, 30, 95, like this. Optical square is not at all required. Clinometer is how, see, this is a hemispherical ball. This is a hemispherical ball. Here it is 0, 10, 20 like this, 0, 10, 20 like this. Now needle will be acting like here. Okay, got it sir, got it sir. Now suppose I am going to Uti. My vehicle is moving in this direction. I am going to Uti. Now I want to find this theta. I want to find this theta. So I will put a clinometer here. This clinometer. This is 0, this is 10, this is 20, this is 10, this is 20. So needle will be pointing here. So whatever the angle they are pointing, suppose it is pointing 7 degree. So theta will be equal to 7 degree. Have you got it? Have you got it? Please let me know. Please let me know. Please let me know. Everyone? Okay. Now offsets are, tell me answers on the comment section. Offsets are, what are the offsets? Offsets are lateral measurement. Many people see the offsets are only perpendicular. No. Perpendicular offset is offset. Perpendicular offset is offset. Yes, agree. But any inclined offset is also a offset called as oblique offset, or also called as tie. So many people think that offsets are only perpendicular. No, it can be literal also. Now this is the chapter all about. This is the chapter all about. Now see, there are some corrections. Correction due to standardization, correction due to slope. What are these corrections? I will tell you. But first question in my mind, or in your mind, or it should be in your mind, that why 7 corrections in tape and only 2 corrections in chain? Chain also there is a temperature effect. Chain also there is L alpha delta T. So why only 2 corrections on chain and 7 corrections on tape? Anybody can please tell me on the comment section. Anybody? Why? Only 2 corrections on chain and 7 corrections on tape. Please, let me check your answers. Come on, come on, come on, come on, come on! Everybody. Okay, no Girish. No Gajula. Those who have written accuracy, those are correct. Those are correct. Guys, tape, already we are measuring very rough value. Tape, already we are measuring very rough value. Least count of a chain can be 20 centimeter, can be different for other chains. Let me tell you, for a normal engineering chain, it is 30 centimeter. Least count or 20 centimeter. So even there are so much defects already. Without all these things, there are so much defect in chain. So you are already doing the big mistakes here because of least count. So why to add all these small values? From tape, we are measuring the more accurate things. That is why we are taking each and every consideration here. Let me tell you a story. Guys, have you seen the movie MS Dhoni? Have you seen the movie MS Dhoni? Have you seen the movie MS Dhoni? Yes. In MS Dhoni, when he was playing the match, before he hit the world famous century against Pakistan, he was telling some person that please remove 50 gram weight from my bat. Remove those slices of wood of 50 gram. Because he want to be more accurate against spinners or whatever. Or fasters. Because he is playing the international match. Because he is playing the international match, that is why he is very, very concerned about his bats. Or even Sachin Tendulkar was even more concerned. Sachin Tendulkar was playing with the heaviest bat in the Indian cricket team. I don't know if you are knowing or not. Sachin Tendulkar is playing with the heaviest bat. I guess the weight of his bat is around 1200-1300 gram. And other players are around 1100 gram. That is why he is having so much elbow injury also. So they are very concerned about their bats. Because they are playing at international level. Suppose now Sachin is playing a charity match like any other match or any friendly match. Or now Sachin is playing in his society. Sachin is playing in his society. Then he will not be saying that remove this 50 gram, remove this 60 gram. So when he wants to be very accurate, then they are taking so many. His chain itself is very inaccurate. Got it now? Got it now? Everyone got it? This is same like that. जितना तुम पीते हो, जितना तुम पीते हो, उतना तो हम पैमाने में छोड़ देते हैं. जितना तुम पीते हो, उतना तो हम पैमाने में छोड़ देते हैं. Got the concept? Okay. Now let us do each and every correction one by one. Okay, standardization correction. Now when I am saying standardization, this is represented by CS. When I am representing standardization correction, it is both for chain also and tape also. Now suppose measured length is L dash. Actual length of the tape is small l dash. Correct distance we will be finding L. And nominal distance 20 meter, 30 meter, whatever is L. Now, please check that L value is L dash by L guys, wait. Don't, if you are reading all these things, actually you are not getting the, if you are reading whatever written here, you are not getting the marathon right. I will explain. Please don't read all these things. Suppose, listen to me if you want to take the benefit. अब जानबूझ के पढ़ेंगे बच्चे, अभी तक नहीं पढ़ रहे होंगे अगर 2-4 तो. Now, please listen to me. Suppose from assuming a tape 30 meter, you are measuring 60. How many times you have put the tape? 2 times. 2 times 30. Suppose assuming a tape to be 30 meter, you are measuring 90. Assuming a tape to be 30 meter, you are measuring 90. So you put the tape 3 times. Assuming a tape to be 30, you are measuring 120. You put the tape 4 times. Assuming a tape 30, you are measuring 45. You put the tape 1.5 times. So assuming the tape to be L, nominal length, 30 meter or whatever, you are measuring L dash. So this is the number of times you have put the tape. Number of chain lengths or tape length. Number of chain lengths. Number of chain length. Number of chain length. Assuming it to be 20 or 30, whatever L value, measuring L dash. So this is the number of times you have put the chain, and every time the length was actually L dash. Got it? Got it? So one here, nothing true into true, false into false. This is true, this is false, this is true, this is true length, this is false length, this is true length. Might be true into true and false into false, maybe for some other notification and some other things. Have you got this concept, guys? And always whenever the tape is bigger, I just prove it there, na? The 30 meter concept. I just prove it there. When tape is bigger, actually it was not written 30 but it was 31. So correction was positive. When tape is bigger, correction is positive. When tape is bigger, correction is positive. When tape is bigger, correction is positive. So when actual tape length is smaller, when tape is bigger, smaller, correction will be negative. Correction negative means error will be positive. Okay. Now, this is the thing, correction of standardization we have done. Correction length, this is the same thing, na? L dash is actual length. The measured length was, see, actual length was, this is the same thing, na? Corrected length L, measured length is L dash, nominal length is L, actual length of tape is L dash. For area, it will be multiplied by square. For area, it is whatever the area you have measured into L dash by L ka whole square. Same for this. Now, if you want to be more concrete, let us do this question. If you want to be more concrete, let us do this question. If you want to be more concrete, let us do this question. Okay, let me write the formula. The correct length is measured length upon L into L dash. Into L dash. Okay. So line true length is 500 meter. So L is 500. Okay, reported to be 502 by assuming it to 20 into L dash. So from L dash is equal to 19.92 meter. And also guys, what is the correction? Correction is true value minus measured value. So true length is 500, measured value is 502. So correction is negative, and negative correction is when the tape is smaller. I told you 30-31 example, when the tape is bigger, correction is positive. So here correction is negative, so tape is smaller. So actual tape should not be 20, it should be lesser value, less than 20. And even why to remember Abhinav Negi's word always? Just let me tell you one example. So here the correction is, you are measuring actually more. Actual value is this, and you are measuring more, 502. 502 you are measuring. Actual value is lesser. You are measuring 502. You are measuring 502. You are measuring 502. Actual value is lesser. So correction has to be applied negative, na? Bigger value you are measuring, na? So we have to apply negative correction to reach here. And guys, when I mean measuring the bigger values, when actually the tape is smaller. When the tape is smaller, suppose 28 meter, markings are on up to 30, 1, 2, 3, up to 30. But it is only 28, length is 28. Then you are measuring it 30, but actual value is smaller, 28. So actual value is smaller, we are measuring bigger when tape is shorter. When tape is shorter. Got it, everybody? Let me know in the comment section. Everybody, let me know in the comment section. Have you got this? Okay. Now, correction, another is correction for slope or correction for ground. Suppose this L cos theta. So, as per map, correction for everything is true value minus measured value. As per map, the true value is this horizontal distance, because horizontal distance we are putting on map. Horizontal distance we are putting on map. So, L cos theta minus L. So, correction due to slope is L 1 minus cos theta. So, this is always negative. And obviously, it will be negative. The bigger value you have to make in smaller value. Bigger value you have to make in smaller value. It has to be negative, yaar. It has to be negative, yaar. It has to be negative, yaar. Got it? Got it? Everyone, and here when theta is given, when h is given, sorry, theta is not given, this is L, this is h. Okay, so what is this value? In that case, correction you have to apply on this value minus h square by 2L. With binomial theorem you can find it. I am not going here. Here it is the derivation, you can find it. Okay, so this is L, this is LH, this is L square minus h square. So correction is true value minus measured value. By opening this as binomial, you will get this. Okay. Now, what is hypotenuse allowance? So, hypotenuse allowance is AC minus AD. AC, that is the length L, and this is horizontal value AB. So, AC minus AD or AB both are same thing. AD or AB both are same thing, L. That is the arc. So, when this is arc, all distances are same. So, AC minus AD or AB, that is hypotenuse allowance. So, what is AC value if this is L? If this is L, what is that value? So, that hypotenuse, that is hypotenuse H upon base is sec theta. So, base is how much? L is sec theta. What is H? What is H? L sec theta. So, L sec theta minus L. So, that is hypotenuse allowance. Got it? Got it? Everyone, please let me know. Now, correction to pull. Guys, do you know that actually the tape manufacturer, the tape factory never makes 30-meter tape. He always made a smaller tape. He always made a smaller tape. He always made a smaller tape. And he is assuming that always while measurement you are applying a pull. And with the pull of PS, of course pull is applied on both sides. It will be elongated and then it will be 30 meter or 20 meter or whatever. Then it will be 30 meter or 20 meter or whatever. After applying the pull of PS, standard pull. Okay. Standard pull PS, it will be 30 meter or 20 meter. After applying the pull. Because if he makes the tape 30 meter, then by application of pull, it will be always bigger. Because application of P, delta is equal to PL by AE. Delta is equal to PL by AE. So if he makes 30 meter, anyhow it will be bigger. So it makes a smaller pull, a smaller tape, 29.999, 29.998 and this. And with application of PS pull, it has become 30. But you, me, everybody who has done the work in lab, in field, have never known this value PS. We applied PM pull anything that is up to our choice. We never know what is PS. In field, we are pulling like anything. Suppose some girl goes and we are very excited. We pull high. So, but there is nothing. आसपास भी 2-4 एकदम मेरी तरह ही काले काले लड़के हैं, कुछ नहीं है, तो ऐसे दोनों ने ऐसे रखा हुआ है टेप। पुल PS से भी बहुत कम, पुल लेस देन PS, देयर इज नथिंग nearby, nothing is there. Suppose somebody comes from computer science, then higher pull, so maybe higher, maybe lesser pull, like this, elongation will be more, so this will be the correction, this much from here it becomes 30 meter, and it can be also PM can be lesser also, so this correction, this elongation is PS into L by E, this is PM into L by E, so correction is difference of that. They have written this as PM and this is PS, PM and this is PS. Of course, if this is a very logical formula, if PM is bigger, the tape is bigger. If PM is bigger than PS, tape is bigger, so correction is positive. If PM is smaller than PS, tape will be shorter than 30 meter. If PM is smaller, you are only elongating till here, then shorter tape, correction negative, then this will be negative. Have you got it? Similarly, due to temperature, guys, it is impossible to make tape of 30 meter. It is impossible to take a tape of 30 meter. Because at every temperature, the length varies of a specimen. At every temperature, the length varies for a specimen. For each and every temperature, length is varying. So, bhai, tape wala says, the company says, the factory says that for this TS temperature, the tape will be 30 meter. If you apply the pull PS and temperature is TS, it will be 30 meter, because at every temperature tape will be different. But in field, tape the temperature may be different. In field, the temperature may be TM. In field, the temperature may be TM also. In field, the temperature may be TM also. Yes or no? Yes or no? Then the correction is again in the same way, that this much correction has to be applied. Whatever the readings you are taking, you are taking the reading 563.7, 36.7 by assuming the tape to be 30 meter. By assuming the tape to be 30 meter, you are taking the readings. But actually it was not 30 meter, because it was 30 meter at TS temperature. There the temperature is something else. Okay. So this much correction has to be applied on the readings. Guys, are you getting or not? Okay. Now sag correction. Guys, actually we want to require the straight values. And suppose you are sagging. This is catenary. This is also called catenary. So here, guys, this straight line is the true value, but you are measuring this measured value. So correction will be positive here or negative here? Correction is positive here or negative here? Correction is positive here or negative here? Correction is positive or negative here? Guys, true value is the horizontal value. But you are measuring the values like this, sag, bigger value. Okay, so measured value is bigger here. So correction will be negative. Pranam. Negative. So that negative value is written here, the formulas are written here, the notations are written here. Okay. Now, guys, sometimes when the tape is designed for making in flat, but you are measuring in catenary, correction will be negative. But sometimes reverse happen. The tape is designed such a way that you are measuring this, then the values will be correct. But you have measured now in flat, then the correction will be positive. Gaming word Pranam. Have you got it, guys? Usually, if nothing is mentioned, we want to measure horizontally, but we are measuring the values like here in the catenary. So correction will be true value minus measured value. It will be negative. True value is smaller. But sometimes reverse engineering happens. The tape is designed for measuring in catenary. What is happening now? Let me tell you. Suppose I know that my students are always measuring like this. Oh, they are not understanding me. They are always measuring the bigger values. bigger length. So what I will do now, I will make a tape of my own such that actually the tape is 0 here, 1 here, 2 here, 3 here. I will make a special tape. I will design it in catenary and I will make tape like 0 here, 1 here, 2 here and so on. I will elongate the values so that guys from A tape the values a cadet or a student will be measuring more, or from B tape. Let me draw it in zoom. B tape is 0, 1, 2, 3 and A tape is 0, 1, 2. From A tape he is measuring more or from B tape? Yes, it will be useful. So guys, from A tape he is measuring less. A tape this distance is measuring only 2. From B tape this distance is measuring 3. So I was knowing that my students are making bigger distance, so I made tape like this. From this tape they will be measuring less. Now they are measuring less due from this tape, but now suddenly my students are measuring the correct distance. They are measuring along the straight line, not in sag. They are measuring along the straight lines. So from measuring the straight lines from this tape they are measuring less. So correction in that case will be positive. So usually tape is standardized on flat, measuring in catenary, correction will be negative. But in an extreme condition, tape is designed for catenary, but you measured in flat, then correction will be positive. Okay, got it? Now guys, correction for MSL is minus HL by R. If certain line is there having L length, then making line here, for making globe purpose, you are projecting everything here. So true value minus measured value, this will be minus HL by R. H is the altitude of that place. From mean sea level. L is the length of that line. R is the radius of the earth. Okay. Correction beam misalignment. Actually, we have to go this true value. Na? Suppose we measure here L1 and L2. So actual distance will be this one here. L1 square minus D square. L2 square minus D square. So this is the true value minus measure value. Okay. Limiting length of offset is depends on this. Okay, there are derivations that I'll give you notes that how much should be the minimum length. This more than that length should not be done, otherwise the error may be there. Okay, now this I'll be taking guys in couple of days, and then this is the schedule guys. Okay, so do you want break? Everyone? This is going on. Okay, structures will be tomorrow. 2 chapters completed. After break, we will study compass survey. Okay. After break, we will study the compass survey. Got it? No sir means you don't want break. Take a break of 10 minutes. Yeah, it's okay. Okay, it's okay. Take a break of 10 minutes. Okay. So we'll study compass survey after break. Compass survey. Okay, so let's meet at 11:10. Only 10 minutes break, yeah. Okay, you don't need, but I need a break. Okay. Now, most important chapter will be coming. Compass surveying, traversing, and leveling. Okay, I just need a break. I have to eat few medicines. Okay.
Okay.
Okay, okay, okay. Ready? So, what have you taken in the dinner? Or in, I guess, break, many of you have already taken the dinner, na? So, what have you done in the break? That should be the question. Guys, please like the session and share with your friends. मैथ नहीं हो, मैथ भी होगा यार. I already told you ना, if I told you होगा तो होगा. If I told you that it will be done, then it will be done, guys. Just give me a minute. Hello. हाँ सर, मैं लाइव हूँ यूट्यूब पे. Okay. So guys, you might be thinking, the teacher is taking class, but everybody is in the team is working on this class to make possible live class, giving notification to students, answering their doubts. So everybody is awake. Chicken Plus Ride was my favorite song. कौन सा? कूं फाया कूं, कूं फाया कूं. What is this, yaar? What is कूं फाया कूं? So ready? Everyone, guys, please share the session so that everybody can enjoy. Okay. So this was our break. Okay. So let's continue then. I hope everybody is refreshed now. Okay, these are the mega workshops, right? I already told you. Now we are going to the most important segment of surveying. Most important segment of surveying. From here, guys, you will be expecting 80% of questions in any exam. I'm not talking of GATE. Yes, in GATE also it is valid, but other exams also, that 80% questions will be asked. 80% questions will be asked from these three topics, and now we are moving to these three topics. Chapter 3, Compass Surveying. Okay. Now, guys, please see what do we do in compass surveying. We take an angle and we take a distance. Now, first of all, in compass surveying, suppose our area is very big like this. Our area is very big like this. Then our first principle is work from whole to the part. Our first principle is work from the whole to the part. So we do parts here by making polygons. Like in chain surveying, we have done triangles, na? Here we do parts by making polygons. Second is, here, second principle is locate a point from at least two measurement. Locate a point from at least two measurement. So this is A, this is B. From A and B, at angle theta we go, at angle theta we go, and particular distance BC, so we got a C point. So here we are locating a point with respect to one angle and one distance, theta and BC. Okay, first principle is work from whole to the part. So here we are dividing our area into number of polygons. And second principle is locate a particular point with respect to two distances, two measurements. So here is one angle, one distance. So what we do here? Actually, we make a traverse here. Okay, actually we make a traverse here. Everyone, please see. So suppose A and B are already two established points. From A and B, we take a distance theta with respect to previous line AB. We take a theta distance, theta angle with respect to previous lines AB, and got a distance and we reach to the C point. So C point is located with respect to angle from previous reference line and to a particular distance. We'll reach to C. After reaching C now, we go at a particular angle. That angle is with respect to previous reference line BC, let it be theta C, and go to a particular distance, we reach D point. Thus we reach now D. From CD, we take a angle from previous reference line, and from previous lines we take angle theta D and go to a particular distance, we reach E, and same process is done with the angle theta E and a distance we reached A. So traversing is actually locating a point from a previous reference line, a particular angle and particular distance, particular angle, particular distance, particular angle, particular distance. So in chain surveying, what is the difference? In chain surveying, only linear measurements are done. Here angle is also done. Here the framework is triangles. Here the whole area is divided into triangles. Here it is done into the polygons. Now, check line and proof lines are required to check the accuracy. In between certain lines are required, offsets are required to check the accuracy. And this is chain surveying is used for small areas. Because if the area is very big, then how you can measure the whole area by tape? Angle you don't have to go to that point now. For measuring the angle you don't have to go to that point now. By here only, by just moving the face of the theodolite or the compass, we can measure the angle. But for measuring the distance, the leader follower have to go there. So this is done for small areas. Now, guys, there are two types of traverse. Open traverse and closed traverse. Now, if anybody I ask you here in the comment box, what is closed traverse? Then you will say, sir, this is closed traverse. Sir, this is closed traverse. I will say, what is the open traverse? You will say, sir, this is open traverse. No. This is loop traverse. This is not open. This is link traverse. And closed traverse can be a link traverse also. Closed traverse can be a link traverse also. If the coordinates of A and last point E are known. If the coordinates of A and E are known. Okay, if the coordinates of A and इसका स्क्रीनशॉट लेना है प्रिंस, या मेरे को बस सिर्फ टाइम बता देना कि इस टाइम पे हुआ था, मैं बाद में खुद ले लूंगा वीडियो. If coordinates of A and E are known, then it is called as closed traverse. So closed traverse definition is not like that dabba band is closed, dabba khula is open. No. Closed traverse definition is that we can apply the check or not. And here the check is there. Like we go down, then we go up, we go down. Summation y coordinate is 0. If the check can be applied. Summation y coordinate is 0. From A to here, we going forward. B to C, we are going forward. C to D, we are coming back. D to A, we are coming back. So in x direction, we reach through the same point. Summation x is equal to 0. That is a check we can apply. So this is a closed traverse. Similarly, the y coordinate of A is 1 and y coordinate of E is 10. Y coordinate of A is 1 and y coordinate of E is 10. Y coordinate of A is 1, y coordinate of E is 10. So that means summation y is 9. From 1 to 10, 9. Suppose A coordinate, x coordinate is 5 and E coordinate, x coordinate is 7. So summation in x direction is 2. We can apply check. But if coordinates are not known, coordinates of first and last point A and E not known, then we cannot apply check, so it is open traverse. So the exact definition of open and close is this, that we can apply the check or not. That is written in the upcoming slides that you can check. Okay. Okay, now the next point. Guys, in chain surveying, we have to find out the angle. In chain surveying, we have to find out the angle. Yes or no? Now the angle of line AB should be defined from a reference. The guy angle from AB from this line is this, from this line is this, from this line is this, angle from AB from this line is this, from this line is this. So we have to make a reference, and that reference is called as meridian. So meridian is a reference with respect to which we are measuring the angles. With respect to which we are measuring the angles. So there are 4 types of meridian. One is true meridian. True meridian is line joining the north and south pole. Okay, that is the true meridian. What is the benefit of true meridian? That it is always fixed. It is always fixed. It is never changing. The true north direction and true south direction is never changing. What is the disadvantage? The disadvantage is that it is not very easy for a common man. It is not very easy for a common man to identify the exact north direction. Exact north direction we cannot find very easily. Yes, roughly I am sitting here in Delhi. I can say that this is north direction. But exactly if we go here, we will reach north. Exactly if we go here, we will reach north. Exactly if we will go here, where we will reach north. That is not easily can be told you. That easily we can't tell you. A common man cannot tell you. Okay. So yes, if he is going here, he will be reaching to north. Yes, but exactly this exactly is which direction? That for that we have to do astronomical observations of sun and star to finding the exact values. Got it? Everyone? What is the benefit? That it is constant. What is benefit? That it is the constant. Now guys, magnetic meridian is what? Let me tell you guys a very interesting story here. Very interesting story here. Suppose this is Earth. This is true north. This is true north. Line joining the north pole. This is true south. Geographical north, geographical south. Geographical north. So line joining them is called as true meridian. Line joining them is called as true meridian. Now listen to my story. Now inside the earth there is iron. Inside the earth there is iron. And that iron is in molten form. That iron is in molten form. Okay, inside the earth there is iron. Iron is in molten form. Every iron behaves as a magnet. And every magnet has a north pole and south pole. Since earth has also the north magnet, that is iron, so earth will be having also a magnetic north pole and magnetic south pole. Because earth has iron behaves as a magnet, magnet has a north pole and south pole. So earth has iron, that will be behaving as a magnet, that will be having a north pole and south pole. Let me tell you, I don't know how many of you know this. Magnetic south pole is here, very near to true north. I can prove you also. Magnetic north pole is here, and it is changing here also. It can be here also after 5 years. Two questions comes in your mind. First of all, I am telling you those two questions later on. First of all, line joining the magnetic poles is called as magnetic meridian. Now, two questions coming here in your mind. Two questions. First question, sir, why magnetic north pole, south pole above and magnetic north pole below? I can also ask a question. So why you are thinking that if near true north it should be magnetic north? Later I'll tell you logical answer. Second question is why it is changing. So let us take second question first. Guys, Earth's core has iron and Earth is rotating its axis about its axis. Earth is rotating about its axis and Earth is rotating about Sun also. Earth is rotating about its axis and Earth is rotating about Sun also. Earth is rotating about Sun also. Okay. Yes. Hi, regard Guru Rajesh. How are you? Okay, so Earth is rotating like this also, about its axis also and about Sun also. So see, suppose I drink water. There is some water inside my stomach. So if I rotate like this, so orientation of water will little bit change. Similarly, the orientation of molten form of iron that is present in the earth crust is changing, and when the iron position is changing, the magnet orientation will be changing, so poles can change. Got it? Now you got it. Now, Rajesh bhai share bhi kar dena yaar. Now you got it. That it is changing. Now, why it is changing? You got it because Earth's iron is changing. Now, why magnetic south pole above, guys? See, when you take a compass, you have a compass in your mobile. In Apple phone it is a compass. Now in other phones also compass. I also have a Apple phone earlier. Still here it is spinning. Still here is spinning. Okay. Now, ऐसे टांके लगा के किडनी निकाल के दिख रहा था ना. Okay. Now, suppose in compass, this is the needle. In the compass, this is the needle. And needle is showing the north direction. So when needle is showing the north direction like this, what do you assume? What do you assume? If needle is showing the north direction like this, what do you assume? You assume that there is north. There is north. Okay, fine. We are already assumed this. Right? It is not like that the north is showing here, we say north is here. No. If north direction is showing here, we assume that is north. And the needle has nothing to do with geographical north. Actually, this N is attracted towards compass magnet south pole. Actually, this is attracting towards magnetic south pole. So, by going to north direction, actually that is true north. But it is attracted towards south pole. So, actually the needle is never showing you the north. Needle is showing you the south pole, magnetic south pole. But magnetic south pole is very near to true north. So, roughly you can say that is north. Got it? But this is attracting towards earth south pole, yaar. This is attracting towards earth south pole. And earth south pole is near to geographical north. Have you got it, everybody? Please let me know in the comment section, guys. Please let me know in the comment section. This is the magnetic meridian. True meridian. See, magnetic meridian is not good. Because it is changing every year. Every year. Because it is changing every year, so it is not that good. It is not that good. Okay? But the benefit is that easily we can find out. That is why we work more on magnetic meridian rather than true meridian, because true meridian is very difficult to find out. Now, grid meridian is not in syllabus. The country has various longitudes. The longitude that is passing through the center of the country, that can be taken as a reference, and arbitrary meridian means any meridian. Now, arbitrary meridian means any meridian. Now, time calculation is, guys, suppose the world map, here is Asia, here is Asia, here is Australia, here is the Africa, here is the Europe, here is North America, here is South America, and here it is Antarctica. 7 continents, 1, 2, 3, 4, 5, 6, 7, yes. Now, from United Kingdom, a 0 degree line is going here, that is passing from Greenwich, a place in London, and there are some longitudes of east, 10 degree east, 20 degree east, and so on. And here are some longitudes of 10 degree west. Here are some longitudes of 10 degree west, 20 degree west, 30 degree west, and so on. These are like this. Now, after one complete rotation of Earth, 360 degree, there is actually 24 hours difference. 1 day occurs. 360 degree of Earth, 24 hours. So 1 degree will be 24 by 60 hours. 1 degree will be 24 by 60 hours. So 1 degree will be 24 by 360 into 60 minutes. So 1 degree longitude difference will be 4-minute time difference. 1 degree longitude minutes difference, longitude degree, 4 minutes. Of course, towards east it will be more time. For example, everybody, suppose here it is 2 p.m. So in 10 degrees, I am not going in various calculation, 10 degree, 30 minutes east, what is the time? 37 seconds, 52 seconds. I am not going calculation, I am going in concept. So suppose at 0 degree, the time is 2 p.m. from London, from Greenwich. Then time 10 degree. In every 1 degree it is 4 minutes. So in 10 degree it will be 40 minutes. So it is east, so it will be more time. So here it will be 2:40 p.m. Suppose here you want time 20 degree west. So at 0 degree it is 2 p.m. So at 20 degree it is 80-minute difference and it is west. Time will be late. They are early, they are late. 40 minutes back. No, 80 minutes back. So 12 how much? 12:40 p.m. and simultaneously you can do like this. Okay, very good, very good. Anil has asked, Mal has asked a good question. Sir, how to find out the local mean time if standard meridian is given and standard time is given? If standard meridian is given, suppose standard meridian is given as 0 degree or whatever it is given. Okay, just same thing, yaar. Suppose how to get standard time from local time. Manish, if in 20 degrees the time is given as 6 p.m. What is the standard time? What is the standard time? So the difference is standard time is 0 degree. Sorry, here. What is the standard time here? So difference is 20 degree. So 20 degree means 80 minutes. So it is towards west. So time will be here will be less. So if it will be 440. Minus 80 minutes here. It will be 440. Simple. Amal, how to find local mean time? If suppose standard meridian is given as, suppose 10 degree is given as standard meridian. Standard meridian is given as this. And here the time is suppose 6 p.m. and let it be 8 p.m. So suppose local mean time is required here at 20 degree west. Here it is required. So 10 to 20 degrees, what is the difference? This is asked in GATE. This is a part of astronomy. This is 30 degree. 30 degree. So 30 degree means 120 minutes. 30 degree means 120 minutes. So if here it is 80 minutes, so 2 hours before here it will be time 6 p.m. Have you got it? Have you got it, everyone? Okay. Now what is bearing? Bearing is the angle from meridian. Okay, suppose this is a line AB. So, and suppose this is a true meridian. So true bearing is alpha. Bearing is the angle. So, angle from true meridian is true bearing. Magnetic meridian can be here, it is changing. Suppose magnetic meridian is here and this angle is beta. So beta is the magnetic bearing. Similarly, grid meridian. Suppose grid meridian is here and this angle is gamma. So gamma is a grid bearing, and so similarly arbitrary also. Okay. Now there are two types of system: whole circle bearing system and quadrantal. Now what is the difference? In quadrantal bearing system, the angle should be not more than 90. In whole circle bearing, angle can be from 0 to 360 anything. In quadrantal bearing, angle should not be more than 90. Whole circle bearing, it can be from 0 to 360 anything. And whole circle bearing, you are measuring from prismatic compass, and quadrantal bearing you are measuring from surveyor's compass. Okay, quadrantal bearing you are measuring from surveyor's compass. Now guys, suppose this is line OA. So quadrantal bearing is, whole circle bearing is simple, measure from north and measure clockwise. That's simple. Whole circle bearing is simple, measure from north, measure clockwise, measure from north, clockwise. OA is 5'1", OB 5'2", OC measure from north clockwise 5'3", OD is 5'4", like this. Now quadrantal bearing is either measure from north and south, but it should not be more than 90, like OA and θ1 east. OB, you cannot measure from north angle will be more than 90, so S θ2 towards east, OC as θ3 towards west, OD and θ4 towards west. Got it? Got it, everyone? Got it, everyone? Okay. Now if the line is here, this might you not be knowing, then this is N90 towards east, or you can say S90 towards east. If line is here, so you can say N90 west or S90 west, both are same. Now what is fore bearing and back bearing? Suppose this is a line AB. From A we are going towards B. So what is forebearing? So go to the first point. The first point is A. Put a compass there. There will be meridian or north direction. Find the clockwise angle. Clockwise angle. Theta 1. So forebearing will be theta 1 of AB. Now AB I am talking, so back bearing. Before back bearing, go to the last point. Last point is B. Put a compass there. It will be showing the north direction. Then measure the clockwise angle. So there will be theta 2. Theta 2 will be back bearing. If it is written as BA, BA, if it is written as BA, now the first point is B. Now the first point is B. Go to the B and find the clockwise angle. Now the theta 2 will be forebearing. And for back bearing, go to the last point. Now if I am saying BA, if I am saying BA, if I am saying BA, so A is the last point. From there measure the clockwise angle. That will be the theta 1, back bearing. Got it? And difference of forebearing and back bearing is 180 degree. If suppose this is a line, see. Suppose this is a line AB. Okay. And put a compass here. Put a compass here. And suppose I am talking of AB. So this theta 1 is forebearing and this clockwise is the back bearing, theta 2. So of course if this is theta 1, this is also theta 1, parallel line concept. Parallel line concept. दोनों में clockwise होगा. Every time forebearing, back bearing is clockwise. So this is theta 1. So theta 2 minus theta 1 is 180 degree. Theta 2 is back bearing for AB and this is forebearing. So either forebearing minus back bearing is AB or back bearing minus forebearing is 180. This is only possible when there is no local attraction. If at station A, there is some magnet nearby, and magnet nearby it deflects like this. There is some magnet nearby and it deflects like this. Then these two lines are not parallel. Then difference will not be 180. So 180 degree difference only comes when there is no local attraction, or one more case, when the local attraction at both the places are same in direction and same in magnitude. Then also the angle lines are parallel. And when the lines are parallel, then again the same concept can be applied. Everybody on the comment section, please give me yes or no. Everybody on the comment section, please give me yes or no. Fast. Fast. Everyone, come on. Come on. Okay. Okay. Now forebearing back bearing difference is 180 degree. If for any line it is given as in quadrantal bearing, N30 east is forebearing, then back bearing, no, simple, just replace N to S and S to N or E to W or W to E. So it will be N in N, replace N from S and E to west. This will be back bearing. You can check from whole circle bearing also. N theta east means the whole circle bearing is 30 degree. 30 degree. And S theta west, S30. So whole circle bearing is 210. So you can see, yes, forebearing and back bearing difference is 180. Yes, it's correct. Yes, it's correct. Yes, it's correct. Got it? Okay. Now, if the whole circle bearing is 315 degree 20 minutes, what is the quadrantal bearing? This is N, this is E, this is S, this is W. And the whole circle bearing is 315 degree 20 minutes. This is equal to 300 degree 15 degree 20 minutes. And this is 315 degree 20 minutes. So what is this angle? This is what is 360 minus this. 360 minus this. So it will be 44 degree 40 minutes, 44 degree 40 minutes. So it will be N 44 degree 40 minutes towards the west. Towards the west. Okay. Now other questions you can do. Now I am coming to included angles. Included angle has a very simple and sweet definition. Applicable everywhere. Why? I don't know why the students are confused. It is a very simple and sweet definition, and it is applicable everywhere. That definition is applicable everywhere. I don't know why students are confused. And that definition is include angle is angle from previous line to forward line in clockwise direction. Include angle is angle from previous line to forward line in clockwise direction. That's it. That's it. Okay. No Jeevan. Now, suppose this is A, suppose this is B, this is D, suppose this is A. This is a clockwise traverse. This is a clockwise traverse. Okay. Now, suppose it is anti-clockwise traverse. A to B, B to C, C to D, D to A. Now, what is the definition of what is the definition of include angle? It is angle from previous line to forward line in clockwise direction. Previous line to forward line in clockwise direction. This is the clockwise direction. Previous line to forward line in clockwise direction. Previous to forward in clockwise. Previous to forward in clockwise direction. So exterior angle is the include angle for clockwise traverse. Exterior angle is the include angle for clockwise traverse. Now let me go in anti-clockwise traverse. Let me go on anti-clockwise traverse. So from previous line to forward line in clockwise direction. This is the clock. Previous to forward in clockwise direction. Previous to forward clockwise direction. Previous to forward clockwise direction. So here the sum of angles that I told you. No need to remember formula. I told you the trip also. 290 minus 4 into 90 degree. And here the sum of angles is 2n plus 4 into 90 degree. The sum of exterior angles is this. Sum of interior angle is this. Everybody got it or not got it? Got it or not got it? Got it or not got it? Please let me know, guys. Everyone out there. Everyone out there. Have you understood? Have you understood? Yes or no? Yes or no? Yes or no? Okay. From here, include angle is forward bearing of next line minus back bearing of previous line. Let me tell you, suppose so include angle here is previous line to forward line. This is the include angle. This is the include angle. And what is at this point B? What is the next line? Next line is BA. So BA forward bearing is go to the first point. Go to the first point and measure the clockwise angle. This is theta 1. What is the back bearing preceding line? Preceding line is CB. For CB, back bearing will go to B point. CB, baad wala point is, the later point is B. So back bearing is this. So include angle is theta 1 minus theta 2. Included angle forward bearing is this minus theta 2. Have you got it? And using such formulas in surveying, if you get answer in minus, just add 360 to it. Suppose you got minus 50, so answer will be 310. Add 360. Suppose you got answer as minus 70, so answer will be 290. Suppose you got answer as minus 160, so just add 360. The value will be 200. Why this term? Why this term? Because actually in surveying you have to measure from north. Clockwise direction. Suppose something is minus 40, so you have measured opposite direction. That means you have measured anti-clockwise. If you are seeing minus 40, so minus 40 will be actually 320. So whatever value you are getting in minus, just add plus. Okay. So guys, Earth has a field like this, and in a magnet the lines comes from North Pole. So North Pole is here and goes to the South Pole. and the angle between the horizontal at a place and these lines is called as dip. Angle between horizontal at a place and these lines is called dip. Suppose I go to poles. So poles, the horizontal is this and the angle that lines are making is 90 degree. So at poles the dip is 90 degree. Dip is angle between these lines and horizontal at a point. Like in equator, horizontal is this. Lines are also this. So they are parallel. So angle is 0 degree. Angle is 0 degree. So dip at equator. Dip means angle between horizontal and lines is 0 degree. Dip at poles. Horizontal is this. Lines are this. So dip is 90 degree. At any other place it is between 0 to 90 degree. Now declination. Guys, very simple topic. If suppose there is a true meridian. True meridian is line joining the geographical poles. And magnetic meridian is here. So we have said it, declination is west. Declination is measured that where? Declination is measured that where? Declination is measured that where the magnetic meridian goes with respect to true meridian. So it is going towards west. It is going towards east. Guys, true meridian is reference because true meridian is a fixed thing. True meridian is a fixed thing. Now what will happen? I told you this in exam. Now what will happen in exam after one month? You said that declination is 2 degree east. So magnetic meridian is here 2 degree east. Okay. 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 Wrong. 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 Guys, declination is reference is true meridian. And from true meridian, magnetic meridian is going towards west. So it is not 2 degree east. It is actually 2 degree west declination. Declination is measured at where the magnetic meridian is going from true meridian. From true meridian, it is going towards west, west declination. From true meridian, it is going towards east, it is going to be east declination. Now, these declination, all the lines, all the places on earth where the declination is same, 2 degree west, 2 degree west, 2 degree west. So line joining the points of same declination is isogenic line, and line joining the points where declination is 0. That means true meridian and magnetic meridian are overlapping. That means true bearing and magnetic bearing are same. That are called as agonic lines. Those are called as agonic lines. Now the variation of magnetic field is due to secular, annual, diurnal and irregular variation. That I'll give you notes, that theoretical thing. Okay. Now local attraction. Guys, we have a magnetic meridian, magnetic needle that is showing towards Earth's magnetic field. Okay. That is showing towards Earth magnetic field. Now somebody has put the compass. Somebody has put the compass near the station, or the iron near the station, or the magnet near the station, or somebody is working with his watch in his hand and watch has some magnet. Oh my God. Oh my God. Okay, then what will happen? That needle will deflect from its original position. Originally, the needle should be attracted towards the Earth's magnetic field. Towards the Earth's magnetic field, but now it is new, changed to here. Changed to here. So local attraction is towards west. Local attraction towards west. That this is, guys, I also call this as right magnetic meridian towards the Earth. This is the wrong magnetic meridian due to some other iron. And reference here is, guys, in right and wrong, what will take reference? In true meridian and magnetic meridian, the stable thing, the true meridian you have taken reference now for declination. In local attraction, from right and wrong, what you will be taking reference? From right and wrong, what you will be taking reference? Of course, the right one here. So from here, right one, the right magnetic meridian means, towards the Earth. Towards the Earth. And wrong means that some other place due to some iron in vicinity. Vicinity means surrounding, and this is taken as a reference, so this is east. Okay. Now this chapter is also over, but let me take some numericals here. Beautiful numericals that will दिमाग खोल देंगे. Observed magnetic bearing is 30 degree. Listen to me. Observed magnetic bearing. Observed means from right or wrong. Please tell me this. Observed is from right or wrong? Observed is from right or wrong? Please tell me. Observed is from right or from wrong? Guys, when it is said as observed, it is always from wrong magnetic meridian. The reason being that it is not more ka pank, it is not feather of peacock, that the needles are two. In a compass, the needle is only one. In a compass, the needle is only one. And when the needle is only one, it is only showing only in one direction. And when it is asked in the question as local attraction, when in the question it is asked as local attraction, obviously it is measuring from wrong one. Let me again tell you. Guys, there is only one needle in the compass, not two needles. It is not like Moor ka Pank. Only one needle. And if there is local attraction, that means the needle is deviated from its original way. If it is local attraction, that means it is deviated from this place. And when it is deviated from this place, that means it is not showing. It is not showing, it is some other thing. It is showing some other things. And some other thing is showing, then only observed will be from there. Observed will be from there. Okay. Now, true bearing of that line is 35 degree and declination is 3 degree east. Declination is 3 degree east. Find local attraction. Find local attraction. Everyone, every commando, every champion, tell me the local attraction. Just whatever given in the question. Draw this on figure. Draw this on figure. This is true meridian. And from true meridian, the bearing is 35 degree. That means this line is 35 clockwise angle we measured, na? 35 degree. Okay. Now declination is 3 degree east. So declination is the angle from true meridian to right magnetic meridian, yaar. Declination is the right magnetic meridian. Okay. So this is right magnetic meridian. This is 3 degree east. So this will be 32 degree. Okay, and from observed magnetic meridian, that means from wrong. From wrong it is 30 degrees. So wrong will be somewhere here. Wrong will be somewhere here. Then only this angle is 30 degrees. 30 degree. So this is 32, this is 30. This is 32, this is 30. This is 32. From right, this is 30. So this angle is 2. So local attraction is 2 degree towards east. 2 degree towards east. 2 degree towards east. Have you understood? Have you understood? Have you understood? Otherwise, let us take one more question. Let us take one more question. Observed magnetic bearing is 45 degree. Local attraction is 3 degree east. Local attraction is 3 degree east. True bearing is 50 degree. Find declination. Declination is angle of the true meridian and the right magnetic meridian. Declination is angle of true meridian and right magnetic meridian. Everyone on the comment section. Everyone on the comment section. Up to it finish the syllabus might be next 2 hours. काफी तो कुछ नहीं होगा, एक आपको मैराथन से जिनने पढ़ा है उनका एक अच्छा सा रिवीजन, एक डीप वे में रिवीजन हो जाएगा, और जिन्होंने नहीं पढ़ा है उनको पता चल जाएगा कि सर्वे में क्या है. देखो आपको ना बहुत से लोग ऐसा बोलते होंगे कि आज जो सर्वे आ जाओ पूरा हो जाएगा. पूरा कैसे हो जाएगा? नहीं, किसी भी मैराथन में पूरा कैसे हो जाएगा? मैं तो बोल रहा हूँ, मैं तो अपना ही मैराथन का नेगेटिव चीज बता रहा हूँ. अगर इस मैराथन में किसी भी मैराथन में वो सब्जेक्ट पूरा हो जाएगा तो फिर भाई जो बच्चे 60-70 घंटे पेड कोर्स में पढ़ रहे हैं वो फिर बेवकूफ है. उनको भी मैराथन में आ जाना चाहिए 1 महीने पहले, है ना. तो मैराथन इज अ वेरी गुड थिंग टू डीपली रिवाइज द सब्जेक्ट, or if you are studying it first time, then getting the knowledge about the subject. Okay, now observed magnetic bearing is from wrong. Observed magnetic bearing is from wrong, and from wrong this is 45 degree. AB. Local attraction is 3 degree east. So from here it is east? No, wrong is not the reference. The right is the reference. Right magnetic meridian is the reference. From here it is 3 degree east. So right magnetic meridian, this angle is 48 degree. And true bearing, from true meridian it is 50 degree. From true meridian, my God, this is 50 degree. So declination is angle from true meridian and right magnetic meridian, that is 2 degree. This is 40, 50 is 40, 2 degree. And from true, with the reference is 2 here. From true magnetic meridian to right magnetic meridian, this is 2 degree. So this is 2 degree east. 2 degree east. Have you got it? Have you got it? Okay. Okay. So this is compass surveying. These 2 sessions I'll be coming up within next 2, 3, 4 days. Okay. So this is the schedule, guys. Right now we are going with surveying, and now tomorrow will be the structures. Tomorrow will be the structures. The expert Krishna sir will be taking that tomorrow. Complete structures. You can join me in Telegram, Civil by Abhinav sir. This is the workshop on 10th of January in app. Okay, and this is the workshop on 15th of January again on app. Okay, so right now we have done this major part is done, guys. The major part is done. Let's go with the small chapters now. Traversing. Traversing, first of all, say that see, from AB, while traversing you take angle, and major distance you go to BC. So it is saying that angle and the distance should be of equal devices. Means, like if I am going to party, it should not be like that I am wearing a wonderful jeans of 30,000 rupees and wearing a t-shirt very bad, not pressed, 50 rupees pressed, not pressed, 30V from here. It should not be like that. So to locate C, we are requiring an angle and we are requiring a distance. So both should be accurate on the same amount. If only one thing is very accurate, of 5 crore rupees instrument you are measuring angle, but distance you are measuring from 2 कौड़ी के instrument, so कोई फायदा नहीं है फिर angle का भी. Because ultimately to reach the C, the angle and the distance both are taken. The angle and distance both are taken. Okay? Got it? Got it? Okay, it is saying that if the theta is the order of error of angular measurement equipment, then in L length you can do an error of delta L. then in L length you can do error of delta L. Okay, suppose this is the question. What I told you, the tan theta is equal to delta L by L. Tan theta is equal to delta by L. Okay, the least count of a compass is 30 minutes. Tan 0 degree 30 minutes and 0 second. Then the order of error in linear measurement equal delta L, or linear, if least count, this delta L by L is asked. So that will be whatever 8.13 mm or whatever it is. Okay. Now guys, see, this 4 some angle should be 360 degree, na? 2n minus 4 into 90. Suppose this is 5 angles. So sum is 2n minus 4 into 90, 90 it will be 540, and here should be 360, and in triangle it should be 180. But we are humans. While measuring these angles, we will be doing some errors. And suppose all angles are measured with same precision, and suppose we will measuring angle 364 degree, true value is 360, so correction is true minus measured, correction is minus 4. So every angle will reduce by 1 1 1 1 if all angles are measured with same precision. If all angles are measured with same precision, then from, if we have measured 364, it should be coming 360. We have measured 364, it is coming 360. So we all will be measuring minus 1 minus 1 minus 1 minus 1 from 4 angles. It's okay, good. But if the measured value is 200, correction here, true value minus measured value is 160 degree, then correction will be plus 40 in every angle. Is it so? Then correction will be plus 40 in every angle. Please let me know. Then correction will be plus 40 in every angle. Plus 40, plus 40, plus 40, plus 40. If it is like that, no. When the error is large, actually we don't correct that time. We repeat our work. From whatever work, the all sum angles are 200. If the error is big, that means we have done some blunder. So there we have to repeat our work. And when the error is small, that means yes, everything is fine, everything we have done correct, there's only small readings or least count errors, then we'll adjust. So what is the Lakshman Rekha? What is the boundary line? That beyond which we will be doing the whole process again, repeating our work, and before which we will be adjusting? That is given by k root n, plus minus k root n. K is given here, constant which depends on least count of theodolite. N is number of sides. Okay. Now what is latitude and what is departure? What is latitude and what is departure? Suppose this is a line, and here this is theta, because we measure theta from north axis, north or south in quadrantal bearing. So latitude is this projection on north south axis. So this will be, latitude will be L cos theta here, projection of that line on the north south axis, and projection of that line on east west axis, that is called departure, L sin theta. If the projection on north south axis, that is latitude, if the projection is in north axis, it is taken as positive. If it is in south axis, it is taken as negative. Suppose the line is this is theta. So latitude here is not plus, it is on now south sides. So L cos theta. Departure is also on west side, it will be minus L sin theta. Got it, everyone? Everyone got it? Like here, The line is OA. So latitude is in north, projection is on the north axis. O, that is L1 cos theta 1. And departure is on east axis, that is plus L1 sin theta 1. Now, suppose I talk of OB. So OB latitude, that is projection on vertical axis in south. So minus L2 cos theta 2. But departure, the projection on horizontal axis is on east. So L2 sin theta 2. OC, this is O. This L3 line. The projection on north-south axis and south axis. So that is minus L3 cos theta 3. And departure will be minus L3 sin theta 3. Similarly this. Now let me tell you a trick. Okay. Because दिल टूट गया तो वो इंतकाम वाला गाना था ना एक, ठुकरा के ओके ओके ठीक है. तो ये तो अच्छी बात है, ये तो अच्छी बात है, ये तो बहुत अच्छी बात. अब इतना मेहनत करो कि कल को तुम ऐसे जगह पे पहुंच जाओ तो उनको लगे कि यार वो गलत हो गया था. और जो तुम्हारा कभी हुआ ही नहीं, इसका मतलब वो तुम्हारा कभी था ही नहीं. जो तुम्हारा कभी हुआ ही नहीं, इसका मतलब वो तुम्हारा कभी था ही नहीं. क्या सही लाइन बनी यार. ओके चलो. वो प्यार ही क्या अरुण, वो प्यार ही क्या अरुण जिसमें शादी हो जाए. ओके चलो चलो चलो. अब एक बात बताता हूं. इफ एंगल यू पुट इन होल सर्कल बेरिंग, इफ एंगल you put in whole circle bearing, then positive and negative sign will automatically come. You don't have to look. Suppose this is L2 line. Here the theta is in this range between 90 to 180. So between 90 to 180 sign is positive, cos is negative. Suppose here 180 to 270. So both sin and cos are negative. And when it is here, the theta is more than 270, less than 360. So cos is positive, sin is negative. So if you put theta in whole circle bearing, then it will be automatically coming plus and minus. बहुत बढ़िया शुभम. मन नहीं लग रहा है, मन नहीं लग रहा है तो सच बताऊं तुम फिर थोड़ा स्ट्रांग बनो यार. मतलब क्लास अब पूरा देखे. जी सर फॉर गिविंग मोटिवेशन. ओके ओके अरुण. जो तुम्हारा हुआ ही नहीं इसका मतलब वो कभी तुम्हारा था ही नहीं. तुमको लगता था कि वो तुम्हारा है, तुमको लगता था कि वो तुम्हारा है. आज वो तुमसे अलग नहीं हुआ है, आज तुम्हें पता चल गया है कि वो तुम्हारा नहीं था. बस इतनी ही सी बात है. तुमको लग रहा है कि कोई तुमसे अलग हो गया है, पर वो अलग नहीं हुआ है. आज तुम्हें पता चल रहा है कि वो तुम्हारा था ही नहीं. तो जब तुम्हें पता चल गया वो तुम्हारा था ही नहीं, तो फिर किस बात का. आज तो तुम्हें सच्चाई पता चल गई. ओके चलो. नाउ गाइस, समेशन ऑफ लैटिट्यूड हियर, latitude of this line. Guys, whenever in surveying we talk on consecutive coordinates. Independent coordinates means that coordinate with respect to a common origin. Coordinates with respect to common origin. But in surveying we work on the consecutive coordinates. The consecutive coordinates means the coordinates of a point with respect to its previous point. Coordinate of AB, B coordinates with respect to A point. Then we go to BC, then coordinate of C with respect to B as origin. If we go to DA, CD, then coordinates of D with respect to C as origin, like this. Okay? 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 So if I go from A to B, so if we in surveying we work on consecutive coordinates. So we put here origin, north, east, south, west. So AB latitude will be on southern side. Sorry, latitude will be on southern side. So it is minus. Then BC, going from B to C, put origin here, previous point. So BC longitude is on north side, so it's positive. Then going to CD, so put here. Then again the latitude is on north side. So from A to B we are going down, B to C we are going up, C to D we are going up, D to A we are going down. Summation latitude is 0. From A we are again coming back to A. From A going right, left, again coming back to A. So summation departure is also 0. Summation latitude, summation departure, both are 0. Summation latitude, summation departure, both are 0 for a loop traverse. Okay, this one. Now, guys, this question I have taken in the morning also today. Suppose in actual field from A, B, this you go to D point, then C, then back to B, then back to A. So from A to D you go, D to C you go, C to B you go, B to A you come back. And actually in the field you have done this. Actually in the field from A you have gone to D, from D you have gone to C, from C you have gone to B, from B again you come back to A. From B again you come back to A. It's perfect. A to D, D to C, C to B, B to A, again you come back to the same point. In actual field also you have done the same point. But actually you are not Rajnikant, you have done your humans. So humans you will be doing some errors. As a human you will be doing some errors. And then when the night after taking the food, if you started on the computer or in your projector or in your drawing you are making, then there is some error. Actual value is here, and when you are plotting, since you are human, not Rajnikant, you will be doing some error obviously. So you reach here. Instead of A you reach A dash. When you are actually the field it is plotted. It is closed. In field is loop. But in map when you are making, it is not coming close because yes, there will be some errors. Not only due to you, maybe due to imperfection in equipment, maybe due to local attraction or anything. So now there is some error. So this is the A value. So correction will be to make this value correct. This is correction. And what is the error? This is the error. Now if coordinate of A and A dash are given, we can find out the magnitude of error, direction of error if the coordinates are given. Okay. So this is the closing error. Guys, there is a relative error of accuracy or relative degree of precision that is equal to the error upon the perimeter, because we cannot say that a bigger error will be more inaccurate work. Measuring this marker's length and doing an error of 1 centimeter and measuring the Delhi to Bombay distance and doing the error of 5 centimeter, even if there is error is bigger, even the error is bigger there, but that is more precise work. Doing an error of 1 centimeter in this marker and doing the error of 5 centimeter between Delhi to Mumbai distance, so that is more better. So we don't compare only E, we should be comparing E by P. Error by perimeter. Okay, that should be the checked. Okay, so guys, after this, these are the schedule. The sir will be telling you tomorrow. Telegram link. This is the workshop that I had told you every time on 10th Jan and 15th Jan. Now this is done. And let me tell you, if leveling is also done na, then 70%, 75% surveying will be completed. Then these will be very 20, 25, 15 minutes chapter for revision. Okay, so let's just chit chat for 5 minutes. Let me make you a little bit fresh, making you a little bit energetic. Guys, I know that all of you, I remember your name now, right now. Tell me first of all your cities and your year. 3rd year, Gwalior. 4th year, Bhopal. Please write down this in comment box. Your year, either your pass out, comma, Indore, like anything. Like please let me know in the comment section. Your cities and in which year you are. Third year, fourth year, second year, first year, or pass out. Fourth Vizag. Okay, Girish. So, Girish, are you enjoying? भाई ये देख रहे हो, फ्रीजर में रखी थी, ये बर्फ हो गई है. इलाहाबाद पास आउट. पास आउट. तमिलनाडु. फोर्थ कानपुर. ओके. यस सर, बिल्कुल. पास आउट दिल्ली. ओके तिक्षा. गॉड्स ओन कंट्री केरला. गॉड्स ओन कंट्री. Pass out. Allahabad pass out. So guys, see, now this is what you call this. This is from inside it is ice. My hands become very chilled. Mango kulfi, yeah. What was that mango flavor? That was a mixed fruit. My hand becomes very cold. Strength test can be down. Yeah, strength and compressive. UCS test. Because it is also like clay, na? Itself is cohesion. Without confinement also it can become straight, na? Without confinement also it can become straight, na? That is why you'd be the UCS test in clay, not in sand. Okay. Shall I ask you 5 minutes random questions for all subjects? Shall I ask you? हाँ फ्रीजर में लगा था यार. Amal, it is already there in our channel. I am asking you questions, randomly. Let us see that who gives the answer first. Ready? Let us see who gives the answer first. Ready? Ready? Okay. Tell me the value of lateral friction. Many of you are still thinking which subject. Then you will coming to answer. Then you are coming to answer. Then you are coming to answer. .35 Eunice. Eunice, you won the prize, yeah. I already transferred the money to you. I transferred to Eunice, Manas, and other 2 days. Arun and Prince. 0.15. Arun is said correct. Okay. Other question can I ask of other subjects also? Can I ask? What is the reaction time in OSD? What is the reaction time in OSD? What is the reaction time in OSD? 2.5. 2.5. My God, Arun. Arun is a prize winner. He's saying 2.5. Arun is a prize winner. He's saying 2.5. Guys, OSD reaction time is 2 seconds. OSD full form, Gaurav Sharma is asking. Overtaking side distance. Overtaking side distance. Yeah, Joshi sir is also here. The champion of highway itself. Okay, guys, in extra winding that is WL square by 2 hours 9.64 by root r something formula. I am not remembering the formula. If length of wheelbase is not given, then what to take? He is saying Goshi sir, good morning. That's a good 12 baj gaye kya? Okay, what is the length of wheelbase? Take some water, you are drinking, hard work for us. Still live, still is live. How are you, sir? I'm good. Okay. Team MCQ is always with us, यार मोहित भाई. मैंने वाटर पूरा ले लिया यार, वाटर सब ले लिया. Tell me. Yes, length of wheelbase is taken as 6 meter. Guys, out of phi index and W index, which is bigger? Out of phi index and W index, which is bigger? Out of phi index and W index, which is bigger? Phi. And area under the unit hadograph represents what? Area under the unit hadograph represents what? Area under the unit hadograph represents what? Quick, fast. Area under the unit hadograph represents what value? Volume of direct runoff. Okay. Volume of direct runoff of depth 1 centimeter. Volume of direct runoff of depth 1 centimeter. What is the minimum grade of concrete in seawater? What is the minimum grade of concrete in seawater? What is the minimum grade of concrete, reinforced concrete in seawater? Reinforced, and for plain concrete it should be 35, na? I guess. For reinforced concrete it is 30. Okay. What is the minimum number of bars that we can put in a circular column? What is the minimum number of bars that we can put in circular column? What is the minimum number of bars that we can put in circular column? And what is the minimum number of bars that we can put a rectangular column? In rectangular. Okay. Now why in compression I am talking of bond stresses, development length? Why in compression it is 1.3 times or 30% more? MPPSC का भी maybe but little मुश्किल है अभी. Why in development length I am talking of, why it is 30% more in compression? Tell me. Okay, leave. Okay, leave. Let's begin. Leveling now. Okay, guys, come back to the first line that I told you when we are starting the surveying. Come back to the first line that I told you when we are starting the surveying. The first line was that objective of surveying. The objective of surveying is to plot various points that are on earth, on the map or plan. Up to now, whatever we are doing, whether it is chain surveying और इसका यार 30% का ऐसा है कि कंप्रेशन हम पुल आउट वाली की बात करते हैं ना, तो कंप्रेशन में तो एंड से भी उसको रेजिस्टेंस मिल रहा है ना. जब हम किसी को पुल कर रहे हैं तो आपको सिर्फ शियर में ही रेजिस्टेंस मिल रहा है उसको पुल करने से, पर कंप्रेशन के समय तो एंड से भी मिल रहा है ना. ओके, नाउ फ्रेंड्स प्लीज, सर आई एम कंफ्यूज. अरे यार, यूनिट वेट ऑफ सॉलिड्स ओनली इंक्लूड्स द सॉलिड दैट इज वेरी वेरी हाई डेंसिफाइड. Okay, that is very, very high densified. And in soil, in saturated soil, it is solid and water both. In saturated soil, it is solid and water both. Okay. Unit weight of solid is only the density of solid. Water and air, the lighter materials are not coming. But in saturated, solid and water both are coming. Okay. Let's begin, guys. Up to whatever we studied till now in surveying, that is, we are drawing plan and map. Still, we have not studied nothing about. We have studied nothing about the height difference. We have studied nothing about the height difference till now. Because the objective, the first thing that I told in the surveying is that in surveying we are finding the difference of we are finding the relative position of various points. So positions can be top and bottom also, na? So till now we have not discussed anything about the height difference. That we will be doing in this chapter. So elevation is the height with respect to any datum. Any datum. But altitude is a better word because here it is the height with respect to the mean sea level. Elevation of this point, my nose, with respect to this can be different, with respect to this can be different, with respect to this can be different. Elevation changes with respect to datum. It is also called reduced level or height. Okay? And datum can be anything, but altitude is a better word because here it is fixed. The datum is mean sea level, and mean sea level of India is at Bombay. And sea level itself is fluctuating. Somebody can ask me, sir, sea level itself is fluctuating. It itself is changing position. How you can make it datum? So guys, we have not made the sea level as datum. The 19 years average, the fluctuation of 19 years we have seen, and that average is taken as the mean sea level. Okay. So axial telescope is the line joining the optical center of objective and eyepiece. This is the telescope. Where the person is standing, there is eyepiece. And where the object is there, that is staff, that is the objective. So line joining the optical center of this is called as line of telescope. Line of sight is the line of crosshair to optical center of objective. Guys, here is a crosshair also, where there are 3 wires. So line joining the middle cross wire and this is called as line of sight. And of course, if there is no error in our telescope, no defect, then line of sight, line of telescope, horizontal line, everything will be same. Everything will be same. Okay. Line of collimation is in leveling line of sight, the horizontal line while observing the readings. When line of sight becomes horizontal, all these are same. Then it is also called as line of collimation. Height of instrument is that suppose this elevation is 100 and the elevation of this line is 102. So this is the elevation, that is the elevation of height of instrument. And this itself distance is 2 meters. Okay. So basically the people think that this is the height of instrument. No. Actually this elevation of this line of sight, elevation of this line of sight, 102, that is called as line of collimation. Reduced level means elevation of plane of collimation. So where we are seeing that ray, that line of collimation, what is the level, what is the elevation of that thing, that is called line of elevation. Okay. Now height of instrument is RL of benchmark. See, suppose this is benchmark and suppose we got this backside. So what is the elevation of this? Benchmark plus backside. Station is here where we put the instrument. Backside is the first reading. After this is done, so first reading is backside. That is usually taken on the plane of known elevation, benchmark. Then readings are intermediate and foresight. After a certain point, there is a very far distance. The readings are not visible. Then we shift the instrument. The first reading is again backside. Then intermediate, foresight. Then again readings are not visible, we can change. And the point where we change the instrument, that is called as change point. At change point, backside and foresight both are done. Okay, at change point, backside and foresight both are done. So first reading taken is backside. The last reading taken is foresight. Then we shift the instrument. After shifting the instrument, the first reading is backside, last reading is foresight, and change point backsides and both sides. Backsides and foresight both are done. Benchmark, nothing important here. Leveling will do one by one. Now what is chromatic aberration? Chromatic aberration is the defect in the telescope dispersion of white light. We are seeing the staff here, but there it is in the Dhanush. The white light dispersed into the various rays of light. The white light dispersed into the various lights with Gyur. That is called chromatic depression. Spherical aberration means that, guys, our line which is coming parallel should pass from focus, na? Our line which is coming to principal axis should pass from focus. If this is happening, no defect. But if it is coming, it is not passing from focus, it is going beyond this, then that is called as spherical aberration. And both of these effects, that chromatic aberration, that white light disperses into the component of colors. We want to see the staff, but we are seeing the rainbow. And this, both are defected by attaching a convex lens earlier. Now, guys, there is a level tube. We have seen this. There is a bubble tube. And in bubble tube, there is some gas pocket also. In bubble tube, there is some gas pocket also. Now, if gas pocket is exactly at the center, that means we are seeing straight. That means we are seeing straight. We are not seeing above. We are not seeing below. We are seeing straight. We are seeing straight like this. Okay. So sensitivity is that there are some graduations. Here in this bubble tube, there are some graduations. Okay. This glass tube, there are some graduations. So one graduation is making how much angle at the center? That is called sensitivity. It is represented in seconds. Why it is represented in seconds? So why the distance of this pen is represented in centimeter? Why the distance between Delhi to Bombay is represented in kilometers? Because it is in that range only. So phi is very, very, very small. You want to represent in radians, you can represent 0.0001 radian. Okay? You can represent it like this. Okay, so Joshi sir, Richa ma'am, all are in the comment section. Excellent, excellent. Okay, student bhi uthhe, teacher bhi uthe. Okay, so guys, phi value is very, very small. That is why it is represented in seconds. What is phi? What is phi? Suppose this distance is d, arc length is d, and this is r. So phi is d by r. This will come in radian. This will come in radian. This will come in radian. So multiply it by 180 by pi to make in degree. Multiply with 60 to make in minutes. Multiply with 60 to make in seconds. Generally the d value is 2 mm. Generally the d value is 2 mm. So if you put the phi value, this will be coming as 412.53 by r. Now if the liquid which is here, if the liquid which is here is highly viscous, if the liquid here is highly viscous, then even if we are tilting the telescope, okay, the liquid is not moving much. The liquid is not moving much. Even if we are tilting the telescope, the liquid is not moving much. That is called low sensitive. That is called low sensitive. That is called low sensitive. That even if we are tilting the telescope, the movement of bubble is not much. It is less sensitive. If the roughness of the glass tube, if from inside roughness increased, so it is not moving fast. The liquid, this liquid synthetic alcohol is not moving fast. That is also low sensitive, less sensitive. Okay, if length is very small, then even you are not able to find the gas pocket is at the center or where. The gas pocket itself is occupying the whole length. Then it is less sensitive. Okay, and if sensitivity is 412.53 by R, and if R value, sensitivity is 412.53 by R, if R value decreased, then also phi decreases. Yes, not increases, it decreases. If R value decrease, magnitude of phi increases, but a bigger phi represents the less sensitive. Suppose phi of this is 5 seconds, that means it is moving 5 seconds, then bubble is moving 1 division. And suppose here phi is only 1 second, then movement of halka sa tilt, little tilt, 1 second. Phi of movement of 1 second. Movement of 1 second is the gas pocket is moving by 1 division. It is highly sensitive. Just movement of 1 division. Just movement of 1 division. Just movement of 2 seconds, 1 second. Just movement of 1 second, bubble is moving. Here bubble is moving after movement of 5 seconds. Less sensitive. Okay. So R value decrease, phi increases, but a bigger phi represents less sensitive. Now, how to find this all things I already told you. How to find sensitivity? Measure, suppose this is your instrument. Find some S distance. First of all, measure this B point, then A point. First measure B point, then A point. First measure B point, then A point. So S is B minus A. S is B minus A. S is B minus A. Okay, and when I am seeing B, when I am seeing A, so when I am seeing B, suppose gas pocket was here. When I am saying A, suppose gas pocket is here. Okay, so this alpha, tan alpha, leave here all this. Tan alpha is S by D. If alpha value is small, alpha is S by D. Okay, in this is radian, degree in seconds it will be 206265. Alpha is this. Now gas pocket is movement corresponding to 1 division. Gas pocket is movement corresponding to 1 division. If here while being to A, the gas pocket moves by n divisions. If gas pocket moves by n division, 3 or 4, so sensitivity is corresponding to alpha by n. So in alpha, the gas pocket is moving from here to here 3 divisions. So but sensitivity is corresponding to 1 division. So alpha by n. So S by ND into 206265. Give me yes or no. Give me yes or no, everybody on the comment section, guys. Everybody on the comment section. Give me yes or no. Why you're giving 6? Okay, this is some previous slide, I guess. Okay. Okay, that is coming off this wheelbase length. Okay. Now, guys, there are two methods from which we do in our field. Let me just explain both of these two. Suppose let me show you the site. Let me show you the site. I am just making any arbitrary values. Suppose this is benchmark of 100. Here is the instrument, here is the instrument like this. And then here I have make, and here are the readings like this. Okay, so here suppose it's 100 and suppose this is 1, not 1. Suppose this is 3. Suppose this is 2. Suppose this is 1. 3, 2, 1. Now Suppose this is 4 and this is 3. Now I will put these values in backside and foresight. I'll put these values in, this is benchmark, this is A, this is B. So first of all, this is backside, first reading, then intermediate, the last reading is foresight. After shifting the instrument, first reading is backside and then foresight. Okay. Now here both backside and foresight are there. This is change point. Now first of all, let me make the table of rise and fall. Let me write here about point, benchmark A, B and C. For benchmark A, B, C. First of all, backside, intermediate side, foresight, rise, fall, elevation. So elevation of A point, benchmark is 100. On benchmark, what is coming? Backside. Backside of 3. Backside of 3. Okay, elevation is 100. Now next point is A. A we got intermediate side 2. So 3 minus 2 is 1. If 3 minus 2 is 1, that is plus 1. So it will be in rise. Rise is with respect to previous point. So 101, it is 101. Otherwise we can do directly here. 100, 3 above is 103. Then 2 is 102. Then we are coming, see this is 103. So all these points are having 103 elevation. 2 below it will be 101. Directly we can do like this. Okay. Now B point we got backside also. Backside is 4 and foresight is 1. 2 and 1 are taken from same statement. 2 and 1 are taken from same instrument. 2 and 1. So we should not subtract 4. We should subtract 1. Because 2 and 1 have relation. They are from the same instrument. 2 minus 1 is 1. So it is again plus. So plus means rise. It will be 102. It will be 102. Okay. Now C point is a foresight of 5. Foresight of 5. Now 1 minus, so we should be doing now 4 minus 5. Because at B you are getting backside also and foresight also. So backside is 4 and foresight is 1. Okay, now guys we should be subtracting 4 and 5. Because 4 and 5 have some relation. They will be taken from same relation. So 4 minus 5 is minus 1. So minus 1 will be inside fall. But we should not write 1, only 1. So fall with respect to previous point. This is 101. This is 100. This is how we make the table. Otherwise we can direct without this table. 100 plus 3, 103. This is elevation 103. 2 below will be 102. 1 below will be 101. So 101 plus 4, 105. So 105 minus 5. Wait. Elevation of B point is 103 minus 102. 102 plus 4, 106. 5 below will be 101. Have you got it? Please let me know in the comment section. Have you got it? Have you got it? Have you got it? Please let me know in the comment section, guys. Come on. Come on. Now, height of instrument method. Point, backside, mid side, foresight, line of collimation and elevation. Okay. Point is benchmark A, B, C. So benchmark, what elevation is there? 100 and backside is 3. Line of collimation is yellow line's elevation. Yellow lines is how much? 100 plus 3. 100 is this is 3. So 103. So A point is from 103 it is 2 below. So it will be 101. A point it is 2. B point foresight is 1. So from 103, 1 below. 103, 1 below. 103, 1 below. So it will be 102. Now elevation of this is 102. So elevation of this 102 is this plus 406. So elevation of this line is 106. Elevation of this line is 106. And this 5 is foresight. So 106 minus 5 is 101. Give me yes or no. Give me yes or no, everyone. Give me yes or no. Everyone. Okay. Now how to find the elevation of this kind of structures? Like this is this. Okay. And here is the staff. This is the inverted staff. This 0, 1, 0 here. 0 here. Then 1, then 2. Like this. And here we take a reading alpha. And at benchmark, we got a backside. At benchmark, we get the value backside. So RL of this point, Chhajja, RL of this T point is RL of benchmark. From benchmark, go above. Backside, we reach here, then above add alpha. Like this. Like this. Everybody give me yes or no. Everybody please give me yes or no, please. Friends, everyone, fast. Fast. Okay, so these questions will take some different session. Okay, now what is the curvature correction? Curvature correction is minus 0.0783 into d square, where d is in kilometer and curvature correction will be coming in meters. Okay, what is this? Guys, actually what we are doing till now in plane surveying, please see what we are doing till now. Suppose this elevation is 100. Suppose this is 2. Suppose this is 2. What we are doing till now, if this is 2, we are saying this is 102, 102, 102, 102, 102, 102, 102, and suppose this is one value. So 102 minus 1 will be 101. So what I am doing, 102, 102, 102, 102, 102, 102. But actually the same elevation is curved, na? But 785. But actually the same elevation points are curved, na? But actually the same elevation points are curved, na? Actually the same elevation points are curved, na? And what we are doing? We are taking the same 102, 102, same elevation points as a horizontal line. But the same elevation points are curved. I told you at the beginning at the level line. Level line. So there is some error. Guys, these things is 102, 102 we can do in plane surveying. Because in plane surveying, for small area, the plane tangent and the curve both are same. The plane tangent and the curve both are same. But for large area, the distance is more. For the large area, distance is more. For the large area, distance is more. Difference is more. So when this is large, we have to apply the curvature correction. This is this one. Similarly, for large area, there will be some refraction of light also. So here the refraction correction is, this is minus, refraction correction is 1/7 of this. So plus it is written here, I guess. This is refraction correction, this is curvature correction, net correction is this. So if you are doing the geodetic surveying, all staff readings should be corrected by this value, where this correction will come in meters and d is in kilometers. Why these readings are there? I told you curvature is coming due to, because I am assuming this 102, 102, 102, 102, 102, 102. But actually same elevations are not the straight line, same elevations are curved. and I am saying this, suppose this value comes 102, 102, 102, 102, 102, 102, I am saying this as 102, but actually this is 102. Refraction correction will also be there because from large distances the rays will become refracted. Okay, and the net correction will be this much, minus 0.0673 d square. Okay, चंद्रमौली आप हैं क्या मॉडरेटर में? चंद्रमौली आप हैं क्या? Okay. Now, guys, standing in my terrace, I cannot see Statue of Liberty. Standing in my terrace, I cannot see Statue of Liberty. So with h height, if I'm standing, I can only see up to a distance. Okay. At most I can see d distance. If I am standing here at h height, so I cannot see here. I can only see d distance. D is the distance of visible horizon, which is given by this value. D is the distance of visible horizon, which is given by this value. Okay. So questions will see some other things. Reciprocal leveling is Okay, guys, what happens now? It is always recommended. That put your staff at the center. Sorry, instrument at the center. Then the corrections has not to be applied. Why? Guys, if you put the instrument exactly at the center, this is A, this is B, this is A, this is B. So if I am not applying correction, so what I will be writing? RL of A plus small a, RL of A plus small a minus B, I will be reaching RL of B. RL of A plus small a reaching here, then minus B, I'll be reaching at RL of B. Without correction, and with correction, RL of A plus A, correction is to be applied. Minus 0.0673 d square. Minus B, in B I have to apply the correction. And if both D's are same, they will be cancelled and it will be coming like this. So that is why it is said that if you put an instrument exactly at the center, correction need not to be applied, because even after applying the correction, you are getting the same values that you are getting without corrections. Getting without corrections. So this is recommended that put the instrument exactly at the center. But if at the center there are some river, we cannot put. If there is some river, we cannot put. Then we do the reciprocal leveling. So here I am not writing the formula. Please check the formulas, or I will provide you. When instrument cannot be put at the center, then we do reciprocal leveling. Okay. So what are contours? Or should I write the formula if you want, yaar? Should I write the formula if you want? If we cannot put exactly at the center, then we do reciprocal leveling. Okay. Now let me write the formula. Suppose this is a landmass, in between it is river. So because of river I cannot put the instrument at the center. So once I put here, we take the reading x1 and take the reading y1 there. Then we put the same instrument here, take the reading y2 here, take the reading x2 here. Then RLB minus RLA is equal to x1 minus y1 plus x2 minus y2 by 2, and here the correction effect has been taken for. Okay, the correction effect has been taken for. Yes, Akib. Okay, reaction effect has been taken for, and the collimation error is x2 minus y2 minus x1 minus y1 by 2 minus 0.0673 d square. D is the distance between the two instrument. Okay. What is this collimation error? Ashish, that is the trick that I have given in daily dose. That even without knowing the formula, we can do this. That trick, if your other students have not seen, the Ashish is saying that I have given this video daily dose. You can search Abhinav Negi's daily dose short trick of surveying reciprocal leveling. There I have told you that even without knowing this formula, we can do this. That I have given their short trick. Now, what is collimation error? What is the collimation error? That if we have to see here, if we have to see this value, straight value, but there is some error in the instrument and we are seeing above, that is collimation error. And above is a collimation error, that means measured value is more and true value is smaller, so it is positive. Error is measured value minus true value, it is positive. So if this value comes positive, it is positive collimation error, that is upward collimation error. If this is coming negative, then it is downward collimation error. Rosmina Masaru, it is better that if you watch that video of mine, daily dose, in this channel only. There I told you that trick. Now what are the contours? What are the contours? Contours are the point of known elevation and contours are the points lining join the point of same elevation. Contours are line joining the point of same elevation. Suppose if I said something as 3250 meter contour, then all these points are having elevation of 3250 meter. All these points are having elevation of 3250 meters. Okay. Now you say that contour intervals not intersect. Somebody says that. Contour intervals not intersect. Yes, they can intersect in a case of cliff. Like if here I am drawing a contour, so suppose this is a 400 meter contour and this is representing these points, 400 meter elevation. These green points are at an elevation of 400 meter and green points is like this. Okay. Now suppose there are yellow points. So yellow points are at an elevation of 500 meter. This 500 meter. So the contours of this 500 meter here. Okay, this is 500 meter. So this contours are like this. So this is intersecting. So contours can intersect. Contours can intersect. But the green plane is representing the green contour is representing 400 green plane and yellow is representing by the yellow plane. So contours can intersect, but this 400 is representing the green plane and 500 is representing the yellow plane. Okay, in case of hill, as we are going here, the value is increasing 500 to these elevations, then 550, then here it is most elevation, and valley it is reverse. At center it is least elevation. At center it is least elevation, and here at center it is highest elevation. Okay. Now tacheometer is a device. Tacheometer is a device from which we measure the horizontal distances. Tacheometer is a device from which we measure the horizontal distances. Okay. So this distance D has to be found out. Now here is a telescope. Now from this telescope, the rays are coming like this. Like this. So this are intersecting here as S, and this D is equal to Ks plus C. K is the multiplicative constant and C is the additive constant. I am once again saying, guys, there is diaphragm na. In this diaphragm there are 3 wires, 1, 2 and 3. So if I am saying this is a staff, then these wires are intersecting here like this. In leveling, I take this value. In leveling, whenever I am saying that that there is a backside reading of 3.635, then backside reading 3.635 is corresponding to this. Backside reading 3.635 is corresponding to this. Okay, so here in staff these are S. Suppose this is 2.1, suppose this is 2.2, suppose this is 2.3, 2.1, 2.2, 2.3. So S will be 0.2. S will be 0.2. So whenever I am seeing like this, whenever I am seeing like this, whenever I am seeing like this, after seeing like this, these wires, these cross wires, stadia hairs of diaphragm intersect here in 3 places. Intersect here in 3 places. Intersect here in 3 places. So that is called as S. 2.31 is 2.1. And distance is given by Ks plus C. So K, if nothing is given for an analytic lens, or if nothing is given, we'll take it as 100. So K is 100, S is 0.2, C is 0. If nothing is given, then we take K 100 and C 0. This is how we measure the distances. This substance bar also. Okay. So D is equal to Ks plus C is here. K is F by I, focal length of the lens upon stadia intercept, and C is F plus D. C is F plus D. Okay, F is the focal length and D, let me tell you what is D. D is, suppose this is the instrument, this is the eyepiece, this is objective, so this is D. This is D, small d. So K is F by I and C is F by D. Now there are various 4 cases in which this will be applied, and only one thing to remember, that let me tell you one case. Let me tell you this case only. In all the case, D is equal to Ks plus C. But please make sure that this is applicable on when line of sight is horizontal. Line of sight is horizontal, or line of sight is perpendicular to the staff. Or line of sight is perpendicular to the staff. Now, suppose I am taking there are 4 cases, I am just doing one case. Suppose this is the ground level. This is the staff, and suppose this is the instrument. Okay, suppose this is the instrument. Okay, what happened to my laptop? Okay, okay, so now everyone please see here. Suppose this is the actual value that we have to see. This is the horizontal line that we have to see. This is the horizontal line we have to see, but line of sight is inclined upward. Line of sight we are seeing upward like this. And this is the alpha angle, parallactic angle. Now guys, D is equal to, we have to measure this D value. D is equal to Ks plus C is valid? No. Because it is valid when line of sight is horizontal. No, line of sight is inclined. Suppose the line of sight, this is not vertical, sorry. This line of sight is suppose theta. Okay, so line of sight is not horizontal, it is not perpendicular to the staff also. It is not perpendicular to the staff also. It is not perpendicular to the staff also. Okay, so here D is equal to Ks plus C is not valid. So what to do here? We'll make an imaginary staff. Here we'll making an imaginary staff. Here we'll be making an imaginary staff like this. So if this distance was S, that is visible by our naked eyes. So this will be S cos theta. This will be S cos theta. If this is theta, to make it perpendicular, if this is theta, to make it perpendicular, we also have to shift this theta. If this is inclined theta here, to make it perpendicular, we have to also make it theta. So now this inclined distance is S cos theta. Now this imaginary staff is perpendicular to the line of sight. Now line of sight is perpendicular to this imaginary staff. Now the distance can come. But here the distance will be coming this one. The distance also comes perpendicular to the staff wala. Distance also comes perpendicular to the staff. So Now this L is equal to K. Staff intercept is not S, is S cos theta plus C. So what is distance? L cos theta. So distance is equal to L cos theta means K S cos square theta plus C cos theta. Got it? Got it, everyone? Got it, everyone? See, similarly the other cases are also there. Okay. So guys, this is the schedule. Now structures will be there by Krishna sir. That will be 10 a.m. tomorrow. Not tomorrow, this is today only. Okay, and you can all find this PDF everything in my Telegram. Civil by Abhinav sir. These are two workshops that I am saying you again and again. One is on 10th of January by Dheeraj sir at 7:30 p.m. and another by me at 15th January at 12:30 p.m. So this chapter done. This done. This done. This done. Okay, area volume is engineering services. And tacheometry is also done. Okay, GPS, GIS, remote sensing, let me tell you here only. Okay, what is GPS, GIS and remote sensing? See, GPS is global positioning system and GPS is to measure the position of a point or of a location. The minimum number of seats, the minimum number of satellites required are 4 to find the accurate position of a location. With 3 satellites also we can find out the position of a location, but that will not be accurate. For accurate positioning, 4 satellites are required. In Earth orbit, there are various satellites for communication, for photography, various locations, various things. But if I talk about the GPS, which are giving us the position, there are 27 satellites, 24 operational and 3 reserved. If somebody is failing, then we'll using those 3 reserve. Yes, but that will give us the position of all points on the earth. For a particular point, only 4 satellites are required. GIS is nothing but that is a you can say a software that tool maps, analyze the data that we obtain from GPS. And remote sensing is the branch of science. Remote sensing is the branch of science which gives us the property of an object without being in touch with it. That gives the property of an object without being in touch with that body. There are 2 types of remote sensing. One is active remote sensing and one is passive remote sensing. Okay, one is active, one is passive. In passive, we use sun as a source of energy for putting the light on an object, and here it is our own source, radium, anything. Okay, let me again tell you. Let me again tell you, all of you, please listen to me. Remote sensing is the branch of science where we get the property of object without being in touch with it. Suppose like thermal scanners. Without touching us, it gives us the fever. That what is the temperature of a body without being in touch. So that is a remote sensing device. So what we do in a remote sensing device, we throw a light. So incident light may reflect, may refract or may absorbed. May reflect, may refract or absorbed. The important thing is reflect, because the reflected rays is again coming back to us. And once the reflected ray is coming back to us, then we can find some then we can find some properties based on the reflected ray. So reflected ray is more important. So reflected ray is more important because only from reflected ray we can find something. Okay. Okay. So this is remote sensing. Now coming to photogrammetry, guys, there is 2 types of photogrammetry. Our syllabus is aerial. Aerial is to find the photo from a camera which is mounted in an aircraft. Aerial photogrammetry. And terrestrial means in the ground only. The photograph, you are taking the photos from the ground only. Now aerial photogrammetry is further three types. Vertical photograph means that you are taking photograph from the air. This is the aeroplane, like this. The axis of camera and the gravity are matching. The axis of the camera and the gravity are matching, but in tilted, gravity is here and axis of camera is here. Here axis of camera is also here and gravity is also here. The difference between tilted and oblique is that oblique is generally a little bit more angle, tilt is more, and tilted is unintentional. Tilted is unintentional. Oblique is intentionally tilted. Tilted means due to wind it is tilted. We want to take photo straight, but due to wind it becomes tilted. Due to wind it becomes tilted. Oblique means you're intentionally tilting it. Okay. Now if I talk about the scale of photograph, then scale of photograph, not going in derivation. Scale is, let me tell you first how the photo is clicked. Let me tell you first how the photo is clicked. What is the process? Guys, please like the session so that everybody can join in. Like the session. Okay. Now, let me tell you how the photo, suppose here is the camera lens and here is the ground. Now, once we click, the rays comes and there is a negative here. There is a negative here. And once the rays are coming from A and B, once the rays are coming, let me explain you here only. This is the camera, rays are drawn. Now this is the negative photograph. Now rays are coming. This negative is a property of a paper that if a point comes, वो छप जाता है वहाँ पे. If a ray comes, that point is marked in that negative. That Kodak negative, if you remember 4-5 years back or 10 years back, Fuji film, brown color negative, that some rays are coming, that point is located there. Some rays are coming, that point is located there. So that negative is put at f distance from the camera lens. Okay, what is scale now? This is called prescriptive projection. Scale is AB upon capital AB. Photo length upon original length, ground length. And by the similar triangle, this will be F upon H minus small h. F is the, not going in detailed derivation, F focal length, H is the flying height above datum, flying height of the aircraft above datum, and small h is the height of ground above datum. Okay, so S is, I am again saying, F is the focal length of the camera, capital H is flying height above the datum, and small h is the height of ground. Now actually scale varies from place to place. Scale varies from place to place because elevation of H, elevation H is the elevation of that point. So elevation is different. Ground is like this now. So elevation of this point is different, elevation of this point is different, elevation of this point is different, elevation of this point is different. So it is changing. So if you want average scale of whole area, it is F focal length flying height minus average elevation of that area. If you want scale of datum only, so the height, small h is the height of that point from datum. So datum height from datum will be 0. This will be SD. This is S average. This is SD. Okay. And of course guys, if XA is the photo coordinate and capital XA is the ground coordinate, keeping the origin same. If in Qutub Minar you have taken origin in photo, then Qutub Minar should be taken origin in real life also. With respect to Qutub Minar as origin, this is the coordinate in photo, then Qutub Minar in ground, in real ground taking an origin, this is the ground coordinate of A point. Then this will be obviously at this ratio of scale. Similarly for Y coordinate. Now, next coming to relief displacement. See, everyone, Leave this. Let me explain you. Leave all this. I don't want anything. Leave. Okay. Suppose this is the ground level. And suppose this is the building, Qutub Minar, anything, having height h. This is point A. This is point B. Suppose here is the camera height, capital H. Now it takes the pictures. It clicks, so rays comes like this. Now here is the negative. So B is projected here, A is projected here. Now when you see this photo, this is the collimation at the center. Then A comes here and B comes here, correct? A comes here and B comes here, correct? 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 A comes here and B comes here. Yes or no? Then actually A and B are over same point in real life. A and B are over same point in real life. A and B, A and B, A and B are over same point in real life, but actually they are moved apart in photo. This is photo. They are moved apart in photo by d distance. They moved apart. This is called relief displacement. This is called relief displacement. That actually A and B are over same point, but in photos their point is different. But in the photo, this is relief displacement. And R is the plotting position of top point. B is the top point. So relief displacement is R, the distance of top point in the photo. H, height of object. Capital H. Capital H here is flying height, not above datum. Capital H is flying height above the base of object. Capital H here is flying height above the base of object. Got it? Got it? Please let me know. Okay. Now there are how many number of photographs are required? Suppose I want, where's photo? Suppose this is the area. So how many number of photographs are required to take the whole area? So this is called longitudinal overlap as a factor of safety, that nothing is missed. Because if you are taking the photo from camera like this, then like this, then you are playing at the edge. Even if 1 second the flight is forward, so it will taking photos like this, and then this will be left out. So we are doing some overlapping as a factor of safety. This longitudinal overlap PL, then here also we are doing this kind of overlap also. Yes, longitudinal overlap here is also, but this is PW, side overlap. Number of photographs, there are two formulas. One is that 1 minus PL, PL will be 30%, 40%, that 0.3. Length 1 minus PS into W. Length is the length of photo, W is the width of photo, S is the scale. And this is the effective area taken by one photo. So number of photos are total area divided by effective area of one photo. Total is 100. Effective area of one photo is 1 meter square. So 100 by 1 will be 100. 100 by 1 will be 100, like this. And one more photograph, one more formula is this. So whatever the values given, according to that you will be applying the formula. So N1 is this, N2 is this. From here N1 and N2 multiplied, you will getting N. Of course guys, here what is the difference between first and second? I was going little fast, so I was not explaining, but let me explain this also. Guys, in first the total area is given. Dimensions capital L, the length of ground, and capital W, width of ground is not given. Capital A is given. Small l and small w is there. Small l and small w is length of photo. Small w is width of photo. But total area of ground is capital A is given. Capital L and capital W is not given. But if capital L, the length of ground, and capital width of ground is also given, then we have to apply this formula. Okay. Now, this is the schedule. This is the complete structural Maha Marathon tomorrow at 10 a.m. These are the 2 workshops that I am telling you again and again. Civil by Abhinav sir is the Telegram group. Now this is done. 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 Tacheometry is done. Photogrammetry is done. This is done. Plane table is just purely theoretical, yaar. Plane table is purely theoretical. Okay, curves and theory of errors are left. Curves and theory of errors are left. Okay. Curves and theory of errors. सो जाओ यार. हरी भाई आप सो जाओ यार, बच्चे पढ़ रहे हैं, बच्चों को एग्जाम है तो हम भी पूरे मेहनत कर रहे हैं, डबल डबल, सुबह भी दिन में भी. आप सो जाओ. ओके, सो कर्व्स पढ़ लेते हैं, 5 मिनट का है. गाइस, व्हेन द रोड इज ना लाइक दिस and then going like this, so if we make road like this, then there is a very sharp turn at V point. Okay, so to avoid that sharp turn, instead of making road like this, we make like this, and from here we make a curve like this. So actually this we avoid, this phase, because otherwise there is a V, at V there is a sharp turn. Okay, now from T1 to T2 actually we provide a curve. From T1 to T2 actually we provide a curve. Now there are 3 types of curve. Simple circular curve means having a constant radius, T1 to T2. Actually here this is in our syllabus, this will be coming, but in real life we don't make this, because if you made this now, that what happens, that centrifugal force is mv square by r. So before T1 straight line r is infinity, so centrifugal force is 0. Just we go to T1, there is a simple centrifugal force mv square by r. So there is a sudden jerk. Before T1 point there is no jerk. As we cross the T1 point, there is a jerk of mv square by r. Sudden jerk is there. Okay, so to avoid that, actually in real life we never make this kind of curve. So what we do, we make a transition curve little bit, then a circular curve. And transition curve is that radius is changing gradually. So r is not very fast changing. R is decreasing very slow. R is decreasing very slow. mv square bar increasing, gradually increasing. So jerk will not be there. So, but okay, in our syllabus it is same radius throughout the curve. Compound curve means 2 different radius, R1 here and R2 here. Reverse curve means like you are going here, like in hills. The vehicle is going like this, then vehicle is like going like this, vehicle is going like this. Dazzling train, toy train is like this. So curvature is changing. Okay, curvature is changing. That is reverse curve. Now this is what I told you, transition curve. Actually we make, but serving they are asking only for circular curve. Now for circular curve there are various points. Okay, deflection angle, theta and all these things. So let me explain you here in my own diagram. Actually this is V, this is delta. So there will be a sharp turn. So we actually make a curve from T1 to T2. Now here is the center O, and this is 90, this is 90, this is 180 minus delta, so this will be delta. Sum of four angles is 360, one is 90, one is 90, so this is 180 minus delta, so this will be delta, so this is half delta by 2 and delta by 2. This green length is length of curve. So of course length of curve L, length of curve theta by r, delta is L by r, so L is equal to r delta, and if delta is in degree, to make in radian it will be pi by 180, simple formula. Now tangent distance, this one. So in this triangle, tan delta by 2 is perpendicular t by radius r, so t is r tan delta by 2, simple again. Now length of long chord, is, if we join these two directly, this total length is L, so this is L by 2. Now if we see this triangle, so sine delta by 2 is L by 2 perpendicular by r, sine delta by 2 is perpendicular L by 2 by r, so from here L is equal to 2r sine delta by 2, simple. Now guys, mid ordinate means if we don't make this curve, we make straight line, then this distance m, the farthest distance if we make the curve and if we make the straight line. Similarly from geometry you'll get this, and apex distance is if we make a straight line and now curve. So what is the farthest distance from the straight line and the curve? If we make it straight line, that will be like this. Now change of t1 is if change of v is given from v minus t, and change of t2 is from t1 go a small l distance, because actual distance from t1 to t2 is small l. Like this a question is we can do. Okay. Now this is done, area volume leave, this is not in gate, done, tacheometry done, photogrammetry done, this is done, this is also theoretical. Let us do only last chapter, that is theory of errors. Ready for the last lap? Everyone guys, come on, put your guys, show some energy yaar, show some energy. नहीं, कोई ट्रिक नहीं है, नो ट्रिक. चलें? अभी थक गए, क्या कर रहे हो? अच्छा, आप में से एक और चीज बताओ मेरे को, कुछ सर्वे बहुत इंटरेस्टिंग होते हैं मेरे को जानना. सबसे पहले बताओ कि आप में से कौन कौन इसमें देख रहा है, इन विच थिंग यू आर वाचिंग दिस सेशन. राइट आंसर्स लाइक मोबाइल, लैपटॉप, डेस्कटॉप, टीवी, प्लीज कंप्यूटर. प्लीज लेट मी नो ऑन द कमेंट सेक्शन in which device you are watching this session. Mobile, laptop, tablet. लैपटॉप में तो अच्छा दिखता होगा यार. मोबाइल. And why you are watching on mobile and laptop both, प्रशांत? क्यों भाई, why both? Why both? ताकि 2 बार लाइक करे. अरे भाई पढ़ लो, लाइक की इतनी जरूरत नहीं है भाई कि 2 से देख रहे हो. डुअल जोश. If I feel bored, I watch in laptop or big screen to feel it like a movie. Okay. But movie there is actress also na. Movie hero. Okay. Done. Okay. Let's begin with the theory of errors. Guys, as I told you, there are three types of error. One is mistake. Mistake means very big error. Mistake means very big error. As I told you earlier only, that instead of 6.7, you are writing 6.9. But 6.9 suddenly girl is going on. And when you are about to read light point, you forget it and then you write 69. So long error. That is mistake. Instead of 6.8, instead of 0.8, you have written 68 like this. Okay. Now, a very large error is called as gross error. Systematic error that follows a particular pattern, as I told you in temperature case, 30, 31, 60, 62, 90, 93. Random errors may be plus and may be minus. Now this chapter deals with this. This chapter, theory of errors, deals with random error, because systematic error, the temperature, pull, sag, we have done already. Now, random errors follow a curve, and it is quite obvious that if I put this as y-axis, if I put this as y-axis, and if I put this as x-axis, then it is quite obvious that small errors are more frequent. 6.7 measuring 6.8, okay. 6.7 measuring 6.6, okay. But 6.7 measuring 7.3 centimeter, less chances. So small errors are more frequent. Frequency will be more. Large errors will be less frequent. Second is, they have equal chance of being positive and negative. Here there is no defect in instrument. Here there is no defect, means it is not like temperature that is always measured plus or minus. So it is carelessness. It is pure carelessness. Can be measured plus more also, can be measured less also. In carelessness, you can measure more also, you can measure less also. In carelessness, you can measure more also, you can measure less also. That is pure carelessness. So it is symmetrical about y-axis. Positive also same, negative also same. And very large errors, 6.7 you are measuring 67,000, is very less chance. This much good girl is not passing from your, तुम्हारी किस्मत से इतना तो कह सकता हूं मैं, ठीक है. So large, small errors are very less. So this is a bell curve, the normal distribution curve. Okay. Now error, we till now are saying measured value minus true value. Till now we are saying error is measured value minus true value. But actually there is nothing true value in surveying. In surveying there is no true value. Nothing. We only measured up to the least count. Whatever the device is allowing us to measure, up to that much least count only we can measure. The true value of an angle can be 30 degree, 36 minutes, 42.8666009252600272656600000001 seconds. A true value can be this. But we can only measure up to the value where our least count is permitting. So we should be writing not measured value minus true value, we should be writing measured value minus most probable value. And most probable value is arithmetic average. If all the readings are of equal weight, most probable value is the arithmetic average. If all readings are of equal value, and it is the weighted average. if all readings are of different value. Got it, guys? Give me yes or no in the comment section. Give me yes or no in the comment section. So standard deviation is summation v square upon n minus 1. Okay, v is measured value minus the most probable value. Sigma square is variance. So say suppose this is 30, 31, 32. What is x bar? X bar is 31. Okay, what is standard deviation? Under root 30 minus x bar. Most probable value is the arithmetic mean. So minus 1 whole square. 31 minus 31, 0 whole square. 32 minus 31 is equal to 1 whole square upon 3 minus 1. Upon 3 minus 1. This is the most probable value. Arithmetic average. Okay. Sorry, sigma. Most probable value is the arithmetic average if all the readings are taken with equal weight. If all the readings are with different weight, it is the weighted average. Now, this is sigma. Variance will be sigma square. Okay. And standard error for single observation is given by this, but all these are having not much physical significance. These are all 90% data samapt in only 2 hours of the day. Okay. Standard error of a single mean is sigma by root n. Okay, this is most probable error associated with a particular value. The maximum chance of being most probable value of the mean is this. These are all statistical value. Okay, maximum error is this. If the error is beyond this 3.29 sigma, if I am saying that mistake na, so what is the boundary line between error and mistake? Large errors are mistake. Large errors are mistake. What is the boundary line? What is the boundary line beyond which we consider the errors to be big? That is 3.29 sigma. Okay, beyond this it is treated as mistake. Now weight. So weight is that suppose the reading is weight 8. Angle A I am giving measure 20 degree and giving it weight 8. And angle B I am measuring it as 10 degree and giving weight 2. Then it only means that angle A is 4 times more precisely taken. Might be the more experienced survey was there, might be the better instrument was there, might be any other thing. Okay. So angle B is 10 degree, angle A is 20 degree. Suppose B weight is 2, A weight is 8. Obviously, which is having more weight, it is more precisely taken. Okay. Now, guys, how much big is the variance of that number? Guys, suppose somebody has taken the reading like this of angle A. And somebody has measured angle A is 40, 30, 20. Which is better is surveyor? This is the better surveyor. His deviation is less. Standard deviation will be less. 1 square, average will be, x bar will be 30 na, 31. So 1 square plus 1 square by under root 2 by 3. His sigma will be 1 square plus 0 square upon 3 minus 1. His sigma will be 10 square plus 0 square plus 10 square by 2. So this sigma is lesser sigma, less deviating. Both the average is 30, but here data is not deviating much. Here data is deviating high. So this is poor. Same value he is measuring sometimes 40. Same value he is measuring sometimes 20. Poor. Okay. So bigger is the variance, less is the weight. Weight is directly proportional to the number of times quantities are measured. Suppose I am giving that angle A is measured 100 times, then average value I am telling you. Angle B is only measuring 2 times. So of course the average which is taken by 100 readings, it is more weight. Okay. Now in leveling line, bigger is the line, more chances of curvature error, more chances of refraction error, so less weight will be given. More is the length, less is the weight. Okay. Now there are some rules. There are some rules of weight. First one, weight of arithmetic mean of number of observations of unit weight is equal to number of observation. Suppose this is an example, this is an example, this is an example. Most probable value is the average. For average, you have taken by a technique, take 40 degree common and take the average of these. So the weight of this average will be weight of arithmetic mean. Weight of arithmetic mean is equal to number of observations. So this is average of 3 data. So weight will be 3. So if the average of 4 data, the weight will be 4. Got it? Got it? Now weight of weighted arithmetic mean is equal to the sum of individual weights. Now suppose this weight is 1, weight is 3. No, mean will not be simple average. Mean will not be simple average here. Mean will not be simple average here. Mean will be the weighted average, taking 40° common and doing the weighted shortcut. So here the mean is the sum of individual weights. 3 plus 2 plus 1, that is 6. Like this. Now if this has been asked in GATE, this has been asked in GATE in PYQ. Suppose A is 70, B is 40, W is 3, W is 2. So A plus B is 110. So weight will be reciprocal of 1 upon reciprocal of sum of reciprocals. Reciprocal of sum of reciprocals. This will be the weight. Now suppose angle A is 60, weight is 4. Suppose this is multiplied by 3. So weight will be divided by the multiplication factor. It is very obvious. When you are multiplying a certain angle, you are multiplying the errors also. When you are multiplying a certain angle, you are multiplying the errors also. And when you are multiplying the errors, the weight should be reduced. These all are on the basis of theory of least square. Suppose angle A is 60, weight is 4. So angle A by 3 is 20. So it is divided by 3, so multiplied by 3 square. Obvious, when it is divided, weights are also divided. When it is divided, weights are also divided. And when weights are also divided, that means, when it is divided, errors are also divided. And when errors are divided, that means it is more, errors are reduced. Errors are reduced means more weight. So if a quantity is multiplied by its own weight, weight is 4 and we are multiplying by its own weight. Okay, weight is 4 and we are multiplying by its own weight. Then it is 4 divided by whatever we multiplied, uska 4 ka square. Okay. Now, if the sign of equations are reversed, then weight remains same. If we multiply by -1, either LHS or RHS or both, weight will be same. If a quantity is added, value constant is added or subtracted, then weight remains same. Weight remains same. Now this is the thing. Suppose I am finding the volume of a room. I am finding the volume of a room LBH. Volume is LBH. Of course, I am not Rajnikant. While measuring the length, I will be doing the error EL. While measuring the width, I will be doing the error EB. While measuring the height, I will be doing the error EH. So if I have done the error in measuring the length, width and height, it can be another thing. Volume is pi r square dh or pi d square by 4 into h, anything. 1 by 3 pi r cube, anything. 1 by 3 pi r square is anything. So if I have done in doing the errors in LBH, there will be error in volume. So that error in volume is given by this. Okay, error in volume, if A is a function of x, y, z and x has some error ex, y has some error ey, z has some error ez, then if x has some error ex, y has some error ey, z has some error ez, then error in A is given by this. So in this case, error in volume ka square, this square also, this is del f del v by del l bh into EL whole square. Del V by del B is LH into EB ka whole square. Del V by del H is equal to LB into EH का whole square. This is the error in volume. This is the error in volume. Got it? Got it, everyone? Okay, so this is upcoming schedules. Okay, within next 2-3 days I'll be teaching this. Okay, how to utilize 3 hours, because for every hour you have done a lot of effort. Okay, now guys, SOM is done, steel is done, environment is done, geotech is done, this is done, this is done, surveying is going on. Now guys, please check all subjects are there, or should I add something else? Engineering mechanics we are adding. Engineering mechanics we are adding. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yes, lots of subjects are there. Surveying is also there. OCF we can add. Yes. Engineering mechanics we are adding. Okay, this will be, Krishna sir will be taking tomorrow, है ना? 10 AM. The Maha Marathon of Structures. Okay, maths तो already मैंने बोल दिया है होगा. Okay, you can join me in Telegram, Civil by Abhinav here. Here I'll be sharing the PDF also of this session. These are the 2 upcoming workshops. This is how to ace GATE 2024 by Dheeraj sir with college and job. Okay, this will be on 10th of Jan, Tuesday at 7:30 PM. It means today only. It means today only. Okay, this I'll be taking on Sunday, 12:30 PM. OCF हो जाएगा. So introduction we have done, linear measurement, compass being traversing, leveling, curves we have done, theory of errors we have done, for tacheometry also we have done, photogrammetry, this GPS. Okay, this we are not done. It's okay. It's okay. So guys, this is very theoretical. That's why I'm giving only these notes to you. Have you enjoyed this? Have you enjoyed, everyone? This is the Telegram group name. This will be, as I said many times now, I told you 10 AM tomorrow. I told you this, na? Complete revision by Krishna sir, and 10 AM. Tomorrow means today, this night only, na? Okay, so I told you in after every chapter structure, every chapter I told you 10 AM morning tomorrow. So this done, this done, this done, this done, this done, this done, this done. This will be now 10 AM today only. So now you will be sleeping or doing what? सर आप बचपन से टॉपर तो नहीं था, टॉपर था मतलब, लेकिन 12th के बाद में कभी भी टॉपर नहीं था. Okay, Arjun with it will do some other class. ठीक है? So thank you guys. Enjoy the session, enjoy the series. Okay, any more doubts, please let me know on my Telegram. I'll be waiting for you. Okay, next 30 minutes. I'm there available on Telegram. Please let me know. Thank you guys. Take care. Good night or good morning. I don't know what to say. Good night. Okay. Thank you.